Good morning, everyone. I warmly welcome you all to the second consecutive Advanced Analytics Symposium organized by OCTAVE. The John Keel's Group Data and Advanced Analytics Center of Excellence and the cornerstone of the group's data-driven decision-making. My name is Asanga Gunawardena and I'm currently working as a senior data scientist at OCTAVE attached with the retail sector. OCTAVE, the John Keel's Group Data and Advanced Analytics Center of Excellence, leverages its distinct position as a thought leader in the industry to collaborate with universities on competitions and knowledge sharing sessions with an aim of pioneering curiosity in data among the innovative youth. The OCTAVE Advanced Analytics Symposium provides a virtual platform for final year university students to present and share the findings of their thesis research projects related to data and advanced analytics with a wider audience of data enthusiasts and industry professionals. Once again, I warmly welcome you all to the second consecutive OCTAVE Advanced Analytics Symposium, and thank you for attending today to observe the 10 finalists compete. Moderator for the day will be Akshila Anurangi. Let me introduce Akshila to you guys. Akshila is currently working as a data science and engineering associate. She earned his bachelor's from the University of Colombo and her area of expertise is applied statistics. Over to you, Anurangi, to proceed with the projects.
Thank you, Asanga. Hello, everyone. Good morning. I'm Anurangi. So first of all, let us move on to the agenda of the symposium today. So we will begin with 10 theses presented by the finalists. So at 9:15 a.m., we will have performance analysis of machine learning classification algorithms in the case of heart failure predictions by Chamira de Silva. At 9:35, we will have a stylometric approach for news reliability detections using machine learning for classification problems by Devminda Abeynayake. At 9:55, we will have a comparative study on data requirements for machine learning and deep learning for classification problems by Ishara Neranjana. And at 10:15 a.m., we will have transparency, audibility, and explainability of machine learning interpretability methods by Janith Vanniyarachchi. At 10:35, we will have disease prediction using machine learning by Jimmy Matthew. At 10:55 a.m., we will have a reverse logistic network model for handling e-commerce returns by Pamal Nanayakkara. At 11:15, we will have customer segmentation system by the team Relevant Analytics. So we have Arun Prashant, Shanmuganathan, and Sadhuni Dayanand as the team. And then at 11:35, we have a study on the influence of international trade, monetary policy and regime shift towards economic growth in Sri Lanka by Ruwani Vitharana. And at 11:55, we will have Sinhala hate speech detection in social media using machine learning and deep learning by W. Siumi Sada Rukshi Fernando. And yeah. At 12:15, we will have anomaly detection in image streams with explainable AI by Team Bits of Erised. So we have Nethmi Wijesinghe, Rashmi Perera, and Nethmi Sellahewa as the team. And at 12:35, we will go to an intermission, and then at 1:05, the announcement of the winners will be happen, and we will conclude the event with the vote of thanks by Dr. Rajitha Navarathna, our principal data scientist at OCTAVE. So for this first session, we have an interesting judges from OCTAVE joining with us today. So let me introduce them as well. So Asanga, the one who actually introduced me also, so he is currently working as a senior data scientist in the retail stream, and he earned his bachelor's in econometrics and business statistics from Monash University. And his areas of expertise are in applications of NLP in retail and apparel industry. And then as the second judge, we have Praveen Ekanayake. So he, who is currently working again as a senior data scientist in retail stream, and he earned his MBA from the University of West London, and his area of expertise are data privacy and computer vision. And as the third person, as the third judge, we have Sarmilan Sivanesasuntharam, sorry about that. Yeah, so who is currently working as a senior data scientist again in the retail stream. He earned his bachelor's from the University of Colombo, and his areas of interest are again in machine learning and predictive modeling. So with that, we can move on to the first presentation. Before moving down to the first presentation, let me walk you through by the outline and the rules and the guidelines of OCTAVE Advanced Analytics Symposium. So the duration of each presentation will be 15 minutes, and at 14 minutes, I will announce 1 minute left so that the presenter can wrap up their presentation, and the presentation must end within that 1 minute after the announcement. And this will be followed by a 5-minute question and answer session with the panel of the judges. So then the presenter must turn on their camera while presenting and share the presentation of their screens. And the winners will be, like I mentioned earlier, winners will be announced at 1:05 p.m. So please make sure you're present at that time. So yeah, so without further ado, we can start the symposium. I would like to remind the spectators to mute yourself and turn off your cameras so that the presenter will not be disturbed. Yeah, so let's move into the first thesis. So the first thesis presentation is performance analysis of machine learning classification algorithms in the case of heart failure prediction by Chamira de Silva. So he has a bachelor in engineering in software engineering from Asian Pacific Institute of Information Technology, and in his research, he predicts heart failure with 7 machine learning classification algorithms accompanied by a comparative performance analysis. Chamira, please turn on your camera and state your name for an audio-visual check. Chamira, I think you're on mute.
Hello. Hello. Good morning. Hope you can hear me right now. Yeah.
Yes, yeah, thank you. And please share your screen with the presentation. Okay, thank you. You may begin. Good luck. And
thank you
I
very
will
much.
Start the timer now. Yeah, you can start up, Samira. Yes.
A very good morning, all of you. So I'm Chamira de Silva, a final year undergraduate from Asia Pacific Institute of Information Technology. Today, I'm here to present a research based on performance analysis of machine learning classification algorithms in the case of heart failure prediction. Moving on to achievements. So this paper has been selected for the International Wireless Communication and Mobile Computing Conference, where is the accepted to be present at the conference. And also, these are the positive comments that have been received for this paper. So next, I will moving on to the abstract. So machine learning is one of the most rapidly developing technologies, and it is currently being utilized in every kind of application. So healthcare industry has been benefiting exponentially from this emerging technology, and among the number of advantages, heart failure prediction is one of them. So almost 79.9 million people die from heart disease every year. So this research predicts heart failure with 7 machine learning classification algorithms by the factors of features of health conditions such as age, resting blood pressure, chest pain type, cholesterol, fasting blood sugar, resting electrocardiogram, maximum heart rate, and etc. Then it is accompanied by comparative performance analysis of these algorithms. So the research shows that naive-Bayes, random forest, and support vector mechanics are outperformed to predict heart failure. The accuracy of these is almost 85% to 86%. Moving on to introduction. Machine learning is one of the most emerging technologies used in almost every application nowadays. It falls under artificial intelligence category. So it uses data algorithms to mimic how humans learn, eventually enhancing accuracy. Some notable machine learning applications include image recognition, speech recognition, virtual assistance, traffic prediction, product recommendation, self-driving cars, stock market trading, email spamming and malware filtering, online fraud detection, medical diagnosis, and automatic language translation. So machine learning can be defined as a fundamental component data science, whereas the use of statistical technique to train algorithms will be to provide the classification or prediction, exposing critical insights in data mining operations. So these insights are subsequently utilized to drive decision-making with applications and companies affecting the key growth matrices in their processes. The primary job of these applications will be data analysis of given facts and hence even facts and predicting results accordingly. Hence, each patient creates massive amounts of health records such as X-ray findings, immunization, blood samples, heart rhythm, DNA sequences, drug reactions, and other prior medical histories, and much more. Moving on to the background. So as different classifications algorithms produce multiple levels of accuracy for a particular domain and feature sets in heart failure prediction, the main problem is to find the most effective algorithm by analyzing the performance of the classification algorithms by the heart failure prediction dataset, which are generic for this prediction. So after experiment is performed, the researchers will be able to see which algorithm are the best for heart failure prediction. So when considering about the background of this process, we will use 7 machine learning classification algorithms, and afterward we will analyze the performance of these classification algorithms in terms of accuracy. The classification algorithms that have been utilized in this study are logistic regression algorithm, k-nearest neighbors algorithm, support vector mechanism algorithm, naive-Bayes, decision trees, random forest, and SDD. So the dataset that I have been used for this research contains the 11 most crucial clinical health features to predict health features in advance. So after making the system, if we input these health features, it will be able to produce the heart failure prognosis. So moving on to objectives. The main research objective of this are to find appropriate datasets which are universal to make sure heart failure prediction. Generally, the dataset should have the features such as age, sex, resting blood pressure, cholesterol, chest pain type, fasting blood sugar, resting electrodiagram, maximum heart rate. So also to implement the most minimalistic 7 machine learning algorithms of ML from the selected data set while analyzing a comparative performance of these algorithms. Furthermore, one of the objectives that needed to be considered is analyze the time and the accuracy of the chosen ML classification algorithms to find the best performative algorithms. Moving on to methodology. Through the methodology, the analysis of this exploratory dataset and the technical stack used in the performance analysis of the chosen algorithm will be discussed. The dataset is open source and consists of 11 features that are critical for health disease diagnosis or prediction. It includes age, sex, resting blood pressure, chest pain type, cholesterol, fasting blood sugar, resting electrodiagram, maximum heart rate, exercise angina, exercise related to rest, and ST segment to heart rate slow. So 6 features have integer values, 1 float, and the remaining 5 variables are object types of this diagram will represent the shape of the dataset that have been used along with the data type, bool value, and the counter before pre-processing. So moving on to the technological stack. So when discussing the technological stack, the library and the framework used to implement the 7 machine learning classifications algorithms are Pandas, NumPy, Matplotlib, and Scikit-learn. And this project is implemented in Jupyter Notebook IDE, and it is used Python 3.8 as the base programming language. Moving on to the results. So as of the results of data analysis took place, the results of performance analysis, performances of the classification algorithms, and the results of the time consumed for data training were achieved for algorithms included with the logistic regression, decision tree, k-nearest neighbors algorithm, support vector mechanism algorithm, random forest algorithm, STD, and naive-Bayes algorithm. And moving forward, so the confusion matrices for the seven corresponding algorithms were analyzed as the confusion matrices will be defining the performance of a classification algorithm while visualizing summarizing the performance. So summarized results of these confusion matrices are for the logistic regression, decision tree, k-nearest neighbors algorithm, support vector mechanism algorithm, random forest algorithm, stochastic gradient decision algorithm, and naive-Bayes algorithm, and the results will be shown as follows. So moving on to, along with this, all the results, all the diagram is plot of the performance of the classification algorithms that have been analyzed to show the accuracy of the selected algorithm. This despite that almost all algorithms are used for heart disease detection are performed well. Almost all algorithms accuracy is around 80. The two best performing algorithms are the random forest algorithm and SVM. The accuracies of those algorithms are 86% and 85% respectively. The worst two performing algorithms are decision tree and STD. The accuracies are 75% and 79%. So the naive-Bayes algorithm is also doing good, and its accuracy is almost 80%, 85%. And other than that, the logistic regression, naive-Bayes, KNN, and take less time to train dataset. SVM and STD took comparatively more time. So based on the research results and considering both accuracy and time consuming factors, naive-Bayes algorithm can be the best predictor. So referring to the figures of the confusion matrices, we can see the tested and predicted numbers more accurately than the how many accurate predictions of heart failure and how many are mispredicted. So moving on to the conclusion. So with the results got from this different analysis process, it can be concluded that the most efficient algorithms are naive-Bayes, support vector mechanics, and random forest algorithm. Other than that, this research is conducted to other necessary steps to find the best performing classification algorithm, naive-Bayes, by the essential factors of features that plays essential roles in the heart failure prediction. The study has explored the 7 classification algorithms in the literature review section. The methodology is given the exploratory data analysis of the dataset and discuss the technologies that used in the research. So in the results section, the paper includes 2 performance analysis tables and display the relevant confusion matrices for each 7 machine learning algorithms. Moving on to the future work. So when considering the future work related to this project, there is a presence and open scope to combine or separately improve the accuracy of this algorithm for further studies. As the projects does not include a deep learning algorithm for the performance analysis, the application of deep learning algorithm of performance analysis is considered as a future scope of this project. This poster is designed to get overall idea about the research, which is based on performance machine analysis of machine learning classification algorithms in the case of heart failure prediction. So this will provide a summary of implementing system with the background, objectives, methodology, analysis, and findings along with the conclusion and future plans of this research. Thank you.
Thank you, Chamira. So judges, do you have any questions for Chamira?
Chamira, Asanga here. Yeah, like I would like to ask what sort of exploratory analysis did you do? Like what sort of hypotheses did you build before you went on to using your predictive models?
Can you repeat your question one more time, please?
Yeah, so if you could just brief on like what sort of exploratory analysis you did before you tried out all these different predictive models.
Yeah, basically, because of I came out this research because a lot of most cases I have seen in they are in the case of this heart failure. So I just want to come up with what is the best performative algorithm to find this heart failure prone. So I just took read past couple of 5 years research papers, and there are some gaps that I have identified. So after that, I thought of coming this implementation. Yeah.
Thanks. Okay.
Shamira, this is Sarmilan here.
Yeah.
Can you explain how did you choose the best accuracy from each models or the algorithms? What's the procedure you kind of chose?
I just input the data, and after inputting, I just calculate the accuracy. And for the testing purpose, I have used this confusion matrices, which I have shown in the presentation. So after that, performance-wise and the accuracy-wise, I have come up with the best algorithm is KNN.
Can you elaborate more on this? For example, you may have found a categorical variable, right? So you can kind of handle categorical in a different way. So how did you kind of adjust that in order to get the best the results from the algorithms? Or do you kind of use a uniform type of input variables to find the accuracy, or you kind of adjust that as well to find the best accuracies?
So in that case, I have used the basic algorithm. So what we have to do is the data set I have just inputted. So after that, to whether it's mispredicted or predicted correctly, that I have used this confusion matrices, which I have shown you. So that's how I get it. Yeah.
Okay, thank you.
Chamira, what were like in your how would you interpret your confusion matrix in the case of like in this heart rate, heart patient predictions? Like, is there any specific metrics that you looked into? In it could be precision or recall or something. What were like the findings there, and what were the metrics that you gave more priority to?
Sorry, I didn't get your question.
Yeah, you said you looked at the confusion metrics. So confusion metrics would have different metrics to like analyze your performance. One is like your overall accuracy, and you will have other metrics. So any specific accuracy measure that you looked at, and like what were your findings for those specific metrics?
So it's like, so basically I have kept it around 70. So as I showed in the presentation, the confusion matrix includes two TP, TNN, FNN, four values. So after that 4 values, I choose the TN value for each algorithm.
Okay, thanks.
Yeah, thank you, judges. So this marks the end of the QA session. So thank you, Chamira, for your interesting presentation. It's truly interesting to see like how the healthcare industry is benefiting from these like emerging technologies. So yeah, we can move on to the next presentation. I hope Devminda Abeynayake is present here. Devminda?
Yeah, I'm here.
Okay, nice. So yeah, so the next thesis presentation is on a stylometric approach for news reliability detection using machine learning approaches by Devminda Abeynayake. So he holds a BSc Hons in industrial statistics from University of Colombo. So yeah, we live in an age where the internet is like filled with sites containing fake news, false and misleading information. So Devminda has done his research to identify a model that can distinguish between reliable and unreliable news article from using a stylometric features. So yeah, Devminda, please turn on your camera and state your name for an audiovisual check.
Hello, my name is Devminda Abeynayake.
Thank you. So please share your screen as well to check if it is working. Yeah.
Is it visible?
Yes, it is visible. And yeah, let me again remind you the rules. So the duration of each presentation will be 15 minutes. And at 14 minutes, I will announce saying 1 minute left. And you will have to conclude your presentation within that 1 minute after the announcement. And then this will be followed by a 5-minute question and answer session with the judges. So you may begin. Good luck. And let me start the timer. And when I said yes, you can start your presentation.
Sure.
Yeah, go ahead. You can start.
Thank you. Hello, everyone. My name is Devminda Abeynayake, and I'm a fourth-year undergraduate from the University of Colombo, following a major in industrial statistics. And my research is a stylometric approach for news reliability detection using machine learning approaches. So this will be the flow of my presentation. So I'll begin with a small background about my research. So before the invention of the printing press, people had to depend on proclamations, notices, and gossip to get hold of news. But the main issue with this method was that it was mostly controlled by the state. But once the printing press was invented, there was this sudden surge in the spreading of news, and this accelerated even further with the introduction of the internet. But alongside this revolution, what happened was there was this increase in the spread of fake news as well, which ultimately led to a misinformed society. Because of this, currently, fake news detection research has become very important. So news reliability detection can be considered as one of these avenues within fake news detection. What I mean by this is if fake news detection is considered to be this big space, within this you have hyperpartisan detection, satire news detection, credibility detection, news reliability detection, and many more. So basically, news reliability detection can be considered as an avenue of fake news detection. Reason I was interested in researching on news reliability detection is because instead of fake news detection was because if you consider fake news detection as this pipeline, the end result would be to determine as of whether an article is fake or real. But even though there have been successful algorithms and models that have been able to automate this process, I still feel that we need to do manual fact checking before we declare an article as fake or real. This is because if you state an article is fake, you're not just going to discredit the article, but you're going to discredit the author of the article, the source of the article, and a whole bunch of other people. So there is an accountability issue that arises from it. But if you're a company that is dedicated at ensuring the society is informed, manual fact checking is going to be too much of work and inefficient. So what you can do is basically add a small filter in the middle of this pipeline such that only the most important articles get pushed through to the endpoint. So one of those filters can be news reliability detection. What it does is it takes on the news, separate the reliable and the unreliable news, and then only push the reliable articles to the endpoint. Reason I was interested in using stylometric features instead of textual features is because stylometric features has the capability to detect the style of writing. So if you take a look at these two paragraphs, you realize that they are referring to the same scenario, but they have two different styles of writing. One of them comes from a reliable source, whereas the other comes from an unreliable source. So I was interested in identifying why there is this difference between these two sources. So one of the reasons for this can be explained through a research done by Mark G. Frank, who has stated that an extra mental effort is required when we are trying to deceive someone. And Afros said, identified that this actually can be reflected in written and verbal communication. So apart from this reason, the other reason as to why I wanted to use stylometric features was because it does not utilize any source-related features or textual features. Significance of this study is that this is the first news reliability detection study done in Sri Lanka. And the combination of stylometric features and news reliability detection is very new. And this research can be considered as very new in the avenue of fake news detection. And it was also trained on a custom-made data set which I created by considering only articles directed at Sri Lanka. Main objective was to create a machine learning models to predict news reliability, and sub-objectives included evaluating the stylometric features and creating a news reliability dataset. So I'm going to run through the methodology very briefly. Initial part of it was to create a data set. In doing so, I had to determine a ground truth to classify an article as reliable or unreliable. Then I had to extract features and then finally do an analysis in which a machine learning model was formulated. So in the dataset preparation process, the initial step was to determine sources for both reliable and unreliable news. This was because I made an assumption when I was creating the dataset, which was that any article that originates from a reliable source was considered to be a reliable article, and any article that originates from an unreliable source was considered to be an unreliable article. So once the sources were determined, I scrubbed the data and cleaned it. So when I was trying to distinguish between reliable and unreliable sources, I utilized three ground truths. One was Cohen's research, the other one was core principles of ethical journalism, and the other one was list of fake and unreliable news sites that was mentioned in previous researches. So once the articles was extracted, I cleaned them and extracted three categories of stylometric features. One was character level features, which are features corresponding to characters within the document. For example, for this can be the rate of special character rate and the rate of words with all uppercase letters. The next category was word level features, which describes words within the document. A few examples for this can be mean word length and lexical richness indexes. The final category was syntactic features, which describes features corresponding to the entire article. And a few examples for this can be mean sentence length and readability indexes. So all in all, there was 31 features that was extracted. And out of this, 4 features, namely average number of special characters, standard deviation of word length, document length in words, and standard deviation of sentence length, were new features that was introduced from this research to the stylometric feature space for news-related studies. Let me move on to the findings and results. So the data set consisted of 14,129 observations, which was divided to 9:1 proportion for training and test sets respectively. And as there was a close to equal distribution between the reliable and unreliable class, I proceeded in using classification accuracy as the main metric for measuring model performance. So initially, I fitted individual models, which included statistical, machine learning, and deep learning models, and all of them were hyperparameter tuned using 5-4 cross-validation. So individually, the extreme gradient boosting model had the highest test set classification accuracy, and because of this, I proceeded further analysis on it. So as you can see from the feature importance plot on the right for the XGBoost model, the mean sentence length, special character rate, and standard deviation of sentence length were the most important variables. What I did next was I removed the least two important variables and refitted the model, and then tried to identify whether there was a significant change in accuracy. As there was no significant change, I retained all 31 features since I wanted to evaluate all the 31 features. So I noted down the final accuracy as 78.2024% for individual models, which was contributed from an XGBoost model. The next step involves stacking models together. For this, I utilized the voting classifier and the stacking modules in the sklearn library. And to determine the best combination of each stacked model, I utilized FIFO cross-validation scores for each combination. So based on the FIFO cross-validation scores, the final voting classifier was made out of an XGBoost model and a gradient boosting model. The stacking classifier was made out of 3 base models, namely a support vector machine, gradient boosting model, and XGBoost model, where the meta learner was a logistic regression model. So as you can see, the stacking classifier has performed better than individual models. And something to notice is that individually, the extreme gradient boosting, and random forest model had the highest test set classification accuracy. But when it came to the best combination for the stacking classifier, it was an XGBoost model, a gradient boosting model, and a support vector classifier. And when we do analysis on the coefficients of the meta learner, we can see that the support vector classifier and the gradient boosting model had a higher weightage than the XGBoost model, which actually was the best individual model. So as I mentioned previously, another sub-objective was to evaluate the stylometric features. And for this, I utilized the SHAP summary plot for the XGBoost model. So for us to explain this plot, what it says is the red color dots depicts a higher value of this specific variable, and blue color dots depicts a smaller value of this specific variable. And how we can interpret this is that higher values of mean sentence length has a positive relation to the reliability class, whereas the lower values of it has a negative relation to the reliability class, or an effect on the reliability class. So this behavior can be observed for mean sentence length, special character rate, and standard deviation of sentence length. But when it comes to the adverb pos tag, it had an opposite relationship in which lower values had a positive impact on the reliable class. So we can illustrate this further by box plots in which you can see the median for the reliable class is higher than the unreliable class for mean sentence length, special character rate, whereas you have a higher median for unreliable class for the adverb pos tag than the reliable class. The relationship that was observed from the mean sentence length can be verified by a research that was done by Judy Burgon in 2003, where she identified that deceivers usually utilize shorter sentences. The next step involved identifying the top most important features for all top 3 performing models. For this, I took the top 30% and identified the most common features for all 3 models, and mean sentence length, standard deviation of sentence length, and rate of special characters was common to all top 3 models. So we can state that they are the most important distinguishers when it comes to separating reliable and unreliable news articles. So as a discussion point, I could start off by stating that one of the main contributions from this study was the data set, which was the first of its kind. And moving on to the performance of models, the logistic model and the support vector machine with a linear kernel did not perform that well for the data. What we can assume from this is that the predictors and the response is not linear related. The boosting model actually outperformed the neural network. This can be caused due to the lack of data, because we know for sometimes neural networks are a little data hungry. And stacking models together actually perform well on the data set than individual models. What we can assume from this is that different models have performed well for different parts of the data. So in conclusion, I can say that reliable news detection is very important and adds efficiency to fake news detection pipeline. The final model from my research was a stacking model, which had an accuracy of 79.052%, which actually outperformed a previous research done by Pothast and came close to a result done by Piot, who had similar researchers to this, but was not the same. And then finally, I can say that there actually exists a difference between the writing styles for reliable news articles and unreliable news articles. And the most important features to determine this can be mean sentence length, standard deviation of sentence length, and rate of special characters. Thank you.
Thank you, Devminda. Judges, do you have any questions for Devminda?
Yeah, Devminda, Asanga here.
Hello, Asanga.
Can you just, yeah, hi, Devminda. Can you just briefly explain, like you said, this was all local articles, right?
Yeah.
Yeah. So, like how, like what were your challenges in collecting these data sets, and what sort of sources did you use? Like, was it like official news sites, or like what you had a mix of online articles and Facebook articles, stuff like that? So, what were your challenges and what were the mix of articles that you took?
Okay, thank you for the question. So I only use news sources in the sense I didn't use any social media or any sort of sources related to social media. Only news sites were utilized. And what I did was I not only concentrated on Sri Lankan news sites, but I went for foreign news sites such as BBC, CNN, and all of these things, and only extracted the data that like articles that talks about Sri Lanka, nothing else. So that's how the composition of the data set was. I hope.
Okay. And how many articles did you have in total in your data set?
14,129.
Okay, that's a lot. Okay. And you had around 31 features.
Exactly, yeah.
Okay.
Hi, Devminda. I'm Praveen here. So, so first of all, a good presentation. It's an interesting research that you have done. So the first question I have is, so given the researches that have been done in this space, how is your study different from the rest? So basically, how did you? Yeah. So basically, how did you find the research gap?
Okay, so first of all, when it comes to, so there have been news reliability detection studies that have been done, but they have utilized different features. They have not utilized stylometric features. And then there has been stylometric features that have been utilized for fake news detection. But the combination of stylometric features and news reliability detection is very new. I did not come across any research that actually had this, which was available on prominent journals. So that would probably state that that's one of the gaps. And I have extracted a couple of new features as well, which can be considered as contributions to the stylometric feature space by referring to different avenues. For an example, stylometry actually began when it's most prominently used in investigations for determining if someone has told the truth in criminal cases. So when they are analyzing documents, they try to check as of whether whether the person has said the truth if he has written something. So I took some features from there as well, and then tried it on the news reliability my feature space. So that would probably be the gap. And on top of that, this is the first when it comes to Sri Lanka, and the data set also creates a small gap between other researchers.
Okay, Devminda, thank you. Just one more question. So,
Sure.
If you were to use your model in a real world scenario, how would you imagine it would be used?
Okay. Basically, Praveen, what I would do is create a pipeline where you send in any sort of data. Let's say an article, you just have to send the entire article, copy paste it and send it through. Then the middle of it, you will have to have feature extraction, a tool to extract the features. And then ultimately you will get the predictions based on the model, based on the feed from each feature to the model.
Okay, Devminda, thank you.
Right, thank you.
Devminda, Asanga here again. Yeah, I'm just curious to know, like, how did you, so your it's a class-based prediction problem, right? Like you're predicting whether it's reliable or not reliable. So when you, whatever machine learning model you applied, how did you classify these, the articles that you collected into these two? Was like someone was reading them through and then doing a classification, or how did it work?
No, so Asanga, so like I said on the presentation, I didn't have an annotator or anyone to actually assist me. What I did was I utilized 3 ground truths, in the sense 3 items. One was Holmes' research, which said, I give you a brief an introduction on it. So Holmes' research states that an individual, if a source has been found to be guilty of producing any sort of unreliable or fake news, that source is unreliable. And then there was this 4 principles of ethical journalism, which has 5 principles. And if one of those was violated, I classified that particular source as unreliable. So for an example, some of these gossip sites actually does not take accountability for what is being produced in it. So that means that's an unreliable source, because that does not adhere to the core principles. So likewise, based on those ground truths, I classified them. And then any article that comes from that particular source was considered to be based on the classification that I've given to the source. It will go forward like that.
Got it. Okay.
Right.
Understood. Thank you.
Thank you.
Yeah. Thank you, judges. So that remarks the end of the QA session. And yeah, thank you, Devminda, too. And I also believe that what you have done is really helpful at a time like this to reduce the spread of false news. So yeah, thank you. So let's move into the third presentation. It's a comparative study on data requirements for machine learning and deep learning for classification problems by S. Ishara Niranjana. So she holds a Bachelor's of Science Honors in Statistics and Computer Science from University of Colombo. So in her research, she has compared data requirements, the effect of the representativeness of samplers, and the effect of the number of features, and the effect of number of hyperparameters of a model with the performance of a classification problem. So Ishara, please turn on your camera and state your name to an audio visual check.
Hello, I am Shah.
Okay, thank you. And can you please share your screen as well? Okay, great. So let me remind you the rules again. So the duration for your presentation will be 15 minutes. And at 14 minutes, I will announce saying 1 minute left. And within that 1 minute, you have to conclude your presentation. And then it will be followed by a 5-minute question and answer session with the panel of judges. So I'll start the timer. When I say start, you can start. And yeah. Okay, you may begin. Good luck.
Good morning, everyone. I am Sharan Niranjana from University of Colombo, and my research topic is data requirements for machine learning and deep learning for classification problems. This is the outline of my presentation, and I will go through the background, introduction to the problem, objectives, significance of the study, methodologies, research, conclusion, and future. So, when starting a research project, everyone has one common question. That is the $64,000 question of statistics and data science students. How much data is needed for my research, and will I be able to get a reasonable accuracy? And most of the time, many will think that in order to build an effective high performance model, there should be large number of data. But how large is a question that is not answered. The amount of data required for machine learning depends on factors like the complexity of the problem and the complexity of the training algorithm. Perhaps someone can look at studies problems similar to their studies as an estimate for this. In many studies, researchers mention their dataset sizes and the accuracies achieved using various algorithms, but they have not mentioned what will happen with reduced data sizes, whether that size of a dataset is adequate in order to carry out a related research, and accuracies of the same research using other algorithms with limited data, and the techniques which will work with limited resources. So according to that main research gap, these are my research questions. What are the factors or parameters that have a bearing on the quantity of data required for a particular task? And what is the effect of the representativeness of the data on the quality of models built? And how does the number of attributes or features affect dataset size? And finally, what is the effect of the number of parameters of a model and hyperparameters of an algorithm on the size of dataset needed for building reliable models? So the objectives are following directly from research questions, and the first objective is to experiment on the effect of different samples of a large data set on model building and training, and to evaluate the factors or parameters that have a bearing on the quantity of data required for a particular task, and the effect of attributes or features on dataset size, and the effect of number of parameters of a model and the hyperparameters of an algorithm on the size of a data set. So let's move to the significance of this study. Recently, Andrew Ng, who is the co-founder of Coursera platform and the head of the Google Brain project, has had a discussion about these data-centric approaches, and they have started a company, and their goal is to help the companies to realize the business and operational value of AI with even limited data. He talked about these projects, and here the steel defect detection can be done manually with 90% accuracy, but their model had around 76% accuracy. They have tried different complex models, but could not improve the accuracy significantly. And then they had tried to get into the data, and they were able to get 93% accuracy. And we all know that data is the food for AI. In a project, 80% of the effort is required for data collection and pre-processing steps. But in the research area, there are only 1% of researchers had done related to the data-centric part, and 99% had been on building complex models. And this study will serve as a reference point for both academia and industry professionals, as well as for decision makers in various real-world situations and application areas, particularly from theoretical point of view. In some cases, there may be too many datasets, and simply collecting and integrating all of them may have a negative effect on model training. And this study can be used for evaluate the performance in such cases using different sampling methods. Let's move on to the methodology. The majority of this study is divided as below into subparts, and first the samples are fitted with all the variables for different sample sizes of 250, 500, 1000, 2500, and 5000. The models were logistic regression, null bias, support vector machine, decision trees, random forest, gradient boosting, stacking, and artificial neural networks with AutoKNS. Then this process was continued with the most important variables up to 90% cumulative importance, and most important variables up to 80% cumulative importance, most important 5 variables, and most important 5 variables with random 5 variables. The classification accuracies from entire dataset is calculated to compare results, and tenfold stratified cross-validation is used to get more accurate results and variance for that measurement. When there is a class imbalance, k-fold cross-validation may not have observation from minority class, and hence stratified k-fold cross-validation is used. Then to evaluate the effect of sample size to different hyperparameters of models, tune the hyperparameters of the base model for each 5 sections and different sample sizes. And finally, discuss the model complexity with respect to dataset size. Finally, repeat the process with stratified random sampling and sampling with equal number of observations for each class randomly. The dataset for this study was taken from OCTAVE machine learning repository. And this dataset is consisting of cartographic variables for predicting forest cover types. And the actual forest cover type for a given observation was determined from US Forest Service data. And the variables are independent. Data is in raw form, and continuous numerical columns of data and binary columns of data for qualitative independent variables are there. These are some of the attributes of the dataset and their types and the descriptions. And this plot shows the amount of observations for each class in the response variable. And there were 7 classes in the response variable, and there is a class imbalance. Let's move on to the data pre-processing parts. There were no missing values in the dataset, but there are many extreme points in the dataset. So to reduce this effect, I used a rubber scaler, and this scaler removes the median and scales the data according to the interquartile range. Let's move to the experimental results. As mentioned in the methodology section, these values are taken for 5 samples of data for 3 different sampling techniques. And there were more than 600 combinations. And this is example for 1000 data points sampled with all features for random sampling technique. There we can see that the classification accuracy is around 72%, and the learning curve also shows that around 700 observations we can get around 72% accuracy. This block spot shows the tenfold cross-validation results for different models. The autonomous artificial neural network model also had around 70% classification accuracy for the same sample. And one of the main concerns of our deep learning models with reduced data is that they will overfit. But here, by adjusting the layers correctly and building a simple neural network, we can get better results. Autonomous checked for 15 different neural networks for the sample and found the best one within the given number of reports. Here you can see the model report and classification report for the sample. So in order to estimate the accuracy for different sample sizes, we use polynomial regression. Here the degree for the polynomial was chosen by reducing the mean square error. After fitting the model, we can use that regression function to predict the accuracy values for samples with higher number of data points. And Optuna was used for hyperparameter tuning. It uses Bayesian optimization and can find the global minimum of the objective function. It cuts off unpromising tiles and converges efficiently than other methods. And the random forest model had the best results as a single model, hence it is used for hyperparameter tuning process. And maximum depth, number of estimators, maximum leaf nodes, and minimum sample split are the hyperparameters that were tuned. Here we can see that there is no significant patterns in those values with different sample sizes. From all the combinations of models, random sampling and stratified sampling had significantly performed higher than undersampling method. And when using sampling techniques, it is better to not change the original class distribution of the population. If the population is imbalanced, stratified sampling would be the better choice. For small dataset, it is better to have small number of variables to get higher performance, since it reduces curse of dimensionality. The results showed that simple models with few important variables had higher results for small datasets. There are no significant patterns in hyperparameters with respect to different sample sizes. And with even small data, deep learning models work well than some of the tree-based models. So let's move to limitations. The effect of different feature encoding methods, missing value imputation methods can be studied more, and also the effect of number of classes in the response variable with dataset requirements need to be experimented. And the result shows that random forest feature importance is biased towards high cognitive categorical variables and numerical variables. This is due to the fact that in scikit-learn, they use Gini importance to measure feature importance. And different feature importance and selection methods also can be experimented. And as future works, this study used Bayesian optimization techniques for hyperparameter tuning, and the effect of different hyperparameter optimization techniques with different data set sizes can be experimented. And also different cost validation methods and their effects can also be experimented. And finally, analyze the effect of number of classes with dataset size with different datasets from different fields. And also another deep learning methods like TabNet, GrowNet can be used for tabular data like this. Thank you.
Thank you, Ishara. Yeah, so judges, do you have any questions for Ishara?
Hi, Ishara. I'm Praveen here.
Hi.
It's a interesting research again, Ishara. I think it's a question that everyone comes across. So this is a question that I asked before too. So can you tell me how is your research different from everything else that has been done in the space? As in how did you find the research gap here?
Yeah, basically in past studies, they have tried different sampling methods, and also they have checked what will happen with increasing dataset sizes. But they have not studies about different results with different number of features, and also they have not studies that different samples like this. And there is also some studies to estimate the accuracies from different sample sizes and how to estimate an accuracy for the increasing number of dataset sizes. But they have used some complex models, and they have not used polynomial regression for that purpose.
Okay, thank you, Ishara.
Ishara, this is Sarmilan.
Yes.
I have a couple of questions. Is it a binary classification problem? Sorry, I didn't kind of notice that.
It is a multi-class classification problem.
Multi-class. Do you have a kind of the ratio percentages, how it's distributed?
Yeah.
Is it uniformly distributed, or it's kind of?
No, it is an imbalanced data set.
Imbalance. So what are the validation matrices that you used to choose the best the accuracy of the models?
Yeah, I didn't compare the models, so I didn't want to check the best model for the dataset. But I wanted to show that we can get high accuracy from even small dataset sizes. So here I used classification accuracy, and I showed the confusion matrices and classification report for the different models. And there we can see that preliminary recall values for the samples, different classes are high.
So what are the accuracies that you get from the models or the algorithms?
for like 250 observations, I was able to get around 72% classification accuracy. And for class wise, for the +3 classes, they have more than 70% accuracy. And those classes were those classes had the highest number of observations in the dataset.
So regardless of the accuracy, you are saying that the number of observations didn't make any kind of impact on the models, right?
There's an effect on some classes, but overall, if there's some in the 250 observations, there were like 30-40% from class 1 and 20% like from class 2 and like 6% from class 3. And apart from that, rest of the classes are very low. And for the original dataset also, they are like for the last categories like 5, 6, 7, the overall accuracy F1 score for that classes were low from the original dataset also.
Okay. Okay, thank you.
Yeah, thank you, judges. So that marks the end of the QA session. So Ishara, thank you again for your presentation, and it was an interesting presentation which was focused more on the theoretical aspect of machine learning. So we can move into the next presentation, but before moving on to the next presentation, we have two more interesting judges from OCTAVE joining for us for the next session. So we have Vithushan Vijayananthan, who is currently working as a data science and engineering associate in the retail stream. And he earned his bachelor's from Staffordshire University, and his areas of expertise are machine learning and computer vision. And then we have Dr. Rajitha Navarathna, works as the principal data scientist at OCTAVE and brings about 10 years of experience in applied machine learning and computer vision. He earned his PhD from Queensland University of Technology, Australia, and prior to joining to OCTAVE, he worked as a computer scientist at Walt Disney Imaginary Labs in USA. Yeah, without further ado, we can move into the next presentation. So we have transparency, auditability, and explainability of machine learning interpretability methods by Nethmee. He holds a BSc Statistics Honors from University of Sri Jayawardenepura, and he has done an interesting research focusing on the interpretability of machine learning models. So Janith, can you please state your name for an audio-visual check?
Hi, my name is Nanayakkara. Can you hear me?
Yeah, can hear. And can you share your screen as well?
Yes. Right. Can you see the screen?
Yes, can see. So let me remind you the rules again. So you will be given 15 minutes to complete your presentation, and at the 14th minute, I will announce as 1 minute left. So you will have to conclude your presentation within that 1 minute, and then it will follow by 5-minute question and answer session with the panel of judges. I will start the timer now. Once I said you can start presenting your presentation. Yeah, you can start now. Good luck.
Hi. So today's topic will be about interpretable machine learning. And when we talk about the topic, a key research that stands out in the literature is the classic Wolf and Husky classifier. So what happens here is what happens here is we are given a set of images that contain huskies or wolves, and we are told to build a model that can classify whether the image contains a husky or a wolf. Now, once we have built this model, we wanted to see what the model is actually looking at by using something called interpretable machine learning methods, or IML methods for short. And what we found out was that it's actually a snow detector, where if the model sees that there's snow in the image, then it gives the prediction wolf, and if not, it'll give the prediction husky. Now, this sparked the conversation that IML methods are really good and could be a valuable addition to the future of machine learning. But recently, things have started to pop up where we are starting to question who will watch all the watchers. And there are many instances where the explanations of IML methods were manipulated. So what if we are reluctant to use IML methods because of these drawbacks? And what if we kept on avoiding using IML methods? Well, look no further than the apple cart algorithm fiasco, where the apple cart algorithm gave a higher credit limit for males versus females, and in other cases in judiciary systems and in face detection systems, there were a lot of racial and gender biases. Now, we understand that IML methods should be used. What if we explore the explainability power of IML methods to understand them better? What if we explored the transparency, auditability, and explainability of interpelled machine learning models? Hi, my name is Nethmee, and I'm an undergraduate in a BSc Statistics honors degree in University of Vijayananthan. And this research is supervised by Dr. Tianga Tharagal. Right, so what are we going to do? We are going to explore the land of IML methods and test out the explainability power. But to do that, if you're going to test out IML methods, we need a way to quantify the structure of the data. Why? Because IML methods rely on the model and the data, and if we change the structure of the data, the IML methods should stay robust to these changes. Now, if we can quantify the structure of the data, then we can generate data by quantifying through that quantification. Now, the simplest form of data is the scatter plot. Now, if we look at this scatter plot matrix, you can simply identify the relationships from there. But if we take it another step forward and even further, it's going to be a lot harder for us to interpret. But what if we looked at the scatter plot in a different way? Now, that would mean we would have to use something called scagnostics. The late Leyland Wilkinson developed graph theory-based scagnostics that quantifies features of a scatter plot into measurements ranging from 0 to 1. Now, so given a data set, we'll be getting 9 different measurements like this, ranging from 0 to 1, called sparse, clumpy, skewed, outlying, monotonic, stringy, skinny, convex, and striated. So for example, clumpy, if the value of clumpy is really high, the data tends to be really clumped together. Now, take, for example, the first scatter plot we saw in the matrix. This scatter plot will have scagnostics like this, with skewed values and convex values being really high. Now, since we have quantification of the structure of the data, how do we generate data from this? We need to reverse this. So earlier, when we were given an n number of xy coordinate pairs, we got a 9 by 1 vector of scagnostic values. Now, when we give a 9 by 1 vector of scagnostic values, we need to get n number of xy data points. So it's pretty obvious the equations aren't exactly one-to-one functions. So what we are going to do is we are going to use some method that can be used to solve this equation. And the idea actually came while I was having dessert. So this is actually a personal story that happened to me while I was having dessert and I was putting some sprinkles on some ice cream. And the idea came like, what if I sprinkle a set of data points on a 2D plot and arrange them in an optimal way? Now, the key here being optimal. Now, the scagnostic itself does not have gradient-based information for me to use optimization methods. So for that, I would have to use something called a meta-heuristic method. And one of the best meta-heuristic methods that worked for my use case was simulated annealing. What happens here is that the algorithm works by setting an initial temperature value, and it decreases the temperature gradually towards 0. And when the temperature is really high, the algorithm tends to select worse solutions in order to explore the entire solution space. And in each time step, the algorithm decreases the temperature, and when the temperature becomes really low, the algorithm tends to select more optimal solution in a greedy manner. Now, since we have the simulated annealing with us, we can build the algorithm. So what happens in the algorithm is we go through these iterations, and in the first time, we set the initial points for the optimization algorithm from a uniform distribution. And then we get the optimized data points. So there'll be, if you want 500 points, you'll be first arranging 10 points on a 2D plot. And when the optimal arrangement for the 10 plots, where the calculated scagnostic value for those 10 points and the expected scagnostic values are close as possible, then we save those optimized data points and into a sample. And in the next round, we use the previously obtained optimized points and add a small error term with a normal distributed error term with a variance to get the starting points for the optimization algorithm. And this continues on until the iterations are over. This algorithm has been packaged together in an open source package called Scatter, and you can install and try it out yourself from this link. And to give a small example, you simply have to mention what the scagnostic measurement that you want, and simply from there you can use it, and it plugs in really well with the tidyverse ecosystem as well. Now we have a data generating method. Now we need an IML. We need to know what sort of landscape the IML methods have. So IML methods come in two flavors: global interpretive methods and local interpretive methods. So global interpretable methods works by giving an overall bird's eye view of the entire model. So the global interpretable methods tells us, based on if I change this feature, how does the entire model react to this change? In local interpretable methods, you give a single instance. You say, okay, can you predict this instance and tell me what were the features that made help take that decision for this specific instance? And what we are going to be exploring today is partial dependency plots for global interpretability, and for local interpretability, we'll be using LIME and SHAP. Right, so we have a data generating method, a background idea on IML methods. We can start diving in. Now, before we dive in, we need to plan. So we need an experimental design. So the first factor we are going to be considering is diagnostic measurement type. And the second factor we are going to consider is diagnostic measurement value. And for each of these treatment blocks, we'll be having 2 replicates. And each of these replicates will be scatter plots generated using scatter. And using this, we tend to find out whether there is an effect from the structure of the data on the IML methods. Now, to evaluate an IML method, we brought in a novel ideology. For that, we will be considering the PDP curves. And PDP curves shows the marginal effect 1 or 2 features have on the predicted outcome of a machine learning model. So here, when the age variable goes from around 18 to 85, we can see that the predicted cancer probability changes from 0.07 to something above 0.1. Now, what actually happens here is when the age variable is changing, we generate a set of instances and then we get the predictions for all of those instances, and then we get the marginal outcome to obtain a single curve that represents how the model reacts to the change in the feature. Now, here you might notice that we are getting a probability here. What if we build a logistic regression model, a surrogate model for the black box model that says this is the function I think the model is approximating, and based on the PDP model, we take another surrogate model that says this is the function I think the PDP curve is trying to explain, and we compare those together and we get an idea about whether there's a disconnect between the black box model and the IML method. So we build a PDP curve on top of the model to get 2 curves, the probability of their prediction belonging to one class versus the other, and then we can take the logarithm of these 2 and then subtract those 2 to get the log odds ratio. Now, logistic regression, on the other hand, is simply regression for log odds ratio. So we can compare the coefficients for a given feature and get an understanding of how different the log odds ratios are. And from this method, what we found out was that the diagnostic measurement does not have a significant impact on the similarity between automated IML methods and the model that is told by the black box model. But we did notice that the sparse data set would try to have a bit of a disconnect. So it would be good. It would be a good idea to keep an eye out on sparse data sets when we are using PDP curves to evaluate them. Right, now we can jump into local interpretability methods. So in local interpretability methods, there are 2 methods, LIME and SHAP. LIME works on 2 principles, interpretability and local fidelity. What LIME does is when given a specific instance, it builds a set of instances around it. It builds a set of perturbations around the given instance and builds a local model that is as faithful as possible to the original model and as simple as possible. So the 2 conditions, interpretability makes sure that the model is simple as possible. Local fidelity makes sure that the local model that LIME builds is as faithful as possible to the original model. SHAP, on the other hand, works on game theoretic Shapley values, where we would distribute the contribution, the difference between the average prediction and the given prediction among the features. And what we do normally is use approximation methods, and there are exact values as well. So approximation takes a lot of computation power, and these sort of the approximation methods tend to take quite a lot of time. Now, with that, we are going to test this out on good old MNIST. So the MNIST dataset is something that has been used in a lot of undergraduate studies and in tutorials. So here we have the medians of all of these images, and we are going to use 2 models, a random forest and a convolutional neural network. The random forest will not get the spatial information of the image because we are going to be flattening out the image the 28 by 28 pixel image into 784 array of features, and we are going to feed it to random forest, while the convolutional neural network will incorporate the spatial information through the convolutions that happen within the network. And as you can see, both models work really well for the testing set. So you can see that if you look at the model performance, random forest and the convolutional neural network have similar performance in this test data set. But if you look at the SHAP explanations, you might notice that in SHAP, these images are taken where we take a set of instances and we feed the instances into the SHAP explanation, and we get the overall importances of each pixel. And then we take the median of all of these images to get one representation that tells, OK, these are the pixels that the model looks at the most for this specific class. And through that, we have seen that this the SHAP values tend to have a bit of a disconnect when it comes when the random forest is used. It can detect 0 and 1, but the rest seems a bit nonsensical. But if you look at convolutional neural networks, the SHAP value seems to have a lot more sense, with 0 and 1 having a sense as well, while 7 and 9 also are seen here, with a special interest put onto the curve right under the hook here of 7 and the curve right under the circle of 9. And you can see small significant patterns of the actual digit in the SHAP values. So here, convolutional neural networks and random forest were used, and SHAP values tend to give a good idea. But the twist comes when you look at Lime explanations. So in Lime explanations, the random forest ones in the value of 1 and 0, there was a certain set of similarity, but the rest were completely nonsensical. And the reason behind this is we are giving a 784 vector to the random forest. So when Lime builds a set of perturbations around it, we will be generating instances in the 784 multi-dimension space, which might not exactly be true images that the model would want to predict. And this would create a kind of disconnect. And that is where we need to be careful. If our model specification is wrong, then we might not get the right explanation that we are looking for. While on the other hand, the convolutional networks were able to divide the images into divide the region of the images into this area was most important, this area was not. And we take when we take the median of all of these together, we tend to see a quite more clearer picture. And what if we took this for the real world? We selected a data set of 100 X-ray images and body parts with 5 classes, and the images were resized to fit in memory constraints. We used a MobileNet V3 model, and the explanations from Lime and SHAP were used, and the results gave us a lot of insights. Right, we made it back home. What did we learn from our journey together? The Lime limitation, there are several limitations for Lime and SHAP. Lime relies a lot of perturbation, so it's not a good idea when there's model misspecification. And if there are correlated features, then the expression might not be sensible. In SHAP, it doesn't consider groupings of features, and the exact values are hard to calculate. Both methods need GPU support, and IML methods should not be used simply because the model performed well. And you need to pay attention to the specification and the structure of your data set, and be careful on IML methods that use perturbation underneath, and inspect some of these perturbations and look at the overall interpretations for each class, and be sure to check how certain your model is of your prediction. And last but not least, it's still a growing field, and with good advancements in the right directions, we can make ML models not so alien to us in the future. Thank you for listening, and a huge thank you to my supervisor, Dr. Thiyanga Tharkala. Check out her work on GitHub at Thiyanga T. And if you have any follow-up questions, you can reach me here, and be sure to check out Scatter as well. Thank you.
Thank you, Janith. Judges, do you have any questions for Janith?
Thanks, Janith. So I have several, Janith.
Yes.
Yes. So can you describe the CNN neural network that you have developed?
For the Lime and SHAP?
Yeah. So how many for the layers you have?
So basically, I used a CNN with two convolutional neural networks and a max pooling layer in between, with a two linear layers at the end. So I wanted to keep it simple, and that is the model that I used.
So you had only 2, is it?
Yes, only 2 convolutional neural networks, convolutional layers. Yeah. And
you had max pool in the middle, is it?
In between max pooling, yes.
And you had did you have a dropout at the end?
Yes, before the linear layer, yes, I did have one. Yeah.
What is the dropout rate?
0.7, if I remember. Yes.
So you are dropping 0.7. Okay. Why do you use dropout at the end?
I use dropout in the end because in case the model complexity goes really high, I wanted to make sure that it is generalizable as much as possible to make it robust, because convolutional networks are notorious for overfitting. And since the MNIST dataset is something that is quite trivially easy, I wanted to make it sure that the model was generalizable as much as possible. That is why I used the dropout layer.
Can you explain the how you have divide the data for this particular experiment? Like, so you are talking about this MS data sets, right? So how many images we had, and what is the split?
Yes. So what I did was, when initially we have 60,000 images for the training set and 10,000 images for the testing set. And what I did was, in the 60,000, because of my memory and CPU budget, I decided to downsample it. And also there was a class imbalance in the digits as well, to ensure that all the classes will have same set of images. I did a random undersampling to get 100 images per class to get 1,000 image sample, and that was the training set, and the testing set was kept as it is.
So you have reduced 59,000 images, is it?
Yes, random undersampling, yes, to fit the budget. Yeah.
Okay, so then why did you use CNN?
Because I wanted to explore and make sure that even in a lower setting, it should be able to work comparatively with the random forest.
Okay, so have you done any other machine learning models? Like
no, I used yes.
Using 1,000 images now. So you drop from 60,000 to 1,000 images, right? So now the question is, okay, why do you need to go after the deep learning approaches for this experiment?
Because yeah. What did you say? I didn't catch the last part.
Yes. What is your thinking process going after the model once we have 1,000 images?
Yes. So when we first have 1,000 images and we first fit a random forest model, we realized that there was a certain disconnect with the Lime and the Sharp values. And because of that, we wanted to see, like earlier, we didn't incorporate any spatial information because we just fed the features as one vector. So what I wanted to see was if we did actually incorporate the spatial information through a small convolutional neural network, even for this 1,000 data set, to see whether the incorporation of spatial information would have an effect. And that is why I decided to use a deep learning method as well to see whether we can see the effect of the spatial information. Yeah.
And the last question, Janet, like what is the time complexity on those two models?
Time complexity in the sense of the time consumed for training the models?
Yeah, training and the testing, yes.
I'm not exactly quite sure of that. Yeah, from what I remember, the time was a bit larger for the deep learning one, while the random forest took a few hours, while the other one took a larger more hours. And I don't have an exact value for that. Yeah.
Okay, cool. And did you have to do any like a primary research before you start this project?
Yes, I did. I actually went through and saw that a lot of people were starting to bring up this topic of how IML methods have this issue. And I wanted to do an exploratory exploratory analysis of seeing how IML methods work when we apply different changes and how they react, so that future researchers can work on top of this to bring new methods that can alleviate all the issues that we found. Yeah.
Okay. Okay. Cool. Thanks. I'll let the judges to us. Thank you.
Thank you, judges. So that marks the end of the Q&A session. So thank you, Janet, again for your presentation. It was really interesting to learn how structural properties of data makes a makes the interpretability easy or hard. So yeah, thank you. Yeah, so we can move into the next thesis presentation. So we have this is prediction using machine learning by Jimmy Matthew. So she has a MSc in big data from University of Stirling, UAE. So in her, like, again, this is a interesting research carried out in healthcare domain, a web lab application for disease prediction system using machine learning. So Jimmy, can you please state your name for an audio visual thing?
Hi, good morning. My name is Jimmy Matthew.
Okay, can you share screen as well?
Sure. Are you able to see?
Yeah, I can see. So Jimmy, let me remind you the rules. So you will be getting 15 minutes for your presentation, and at the 14th minute, I will be announcing saying 1 minute left. So once I announce, you have to complete your presentation, conclude it within that 1 minute, and then it will be followed by 5 minutes Q&A session with the panel of judges. So let me start the timer. So once I do that, you can start. Yeah, you can start. You may begin. Good luck.
Thank you. Every human being is the author of his own health or disease, and health is a state of complete harmony of body, mind, and spirit. The adoption of technology in the healthcare over the years have led to the better diagnosis and treatment of disease. And that too, machine learning application in the healthcare helps to improve the accuracy of treatment protocols. A very good morning to all the members and my dear friends who are present over here. My name is Jimmy Matthew, MSc Big Data student at University of Stirling, Ras Al Khaimah, UAE. I'm here to present a project on disease prediction of two diseases, that is chronic kidney disease and diabetes. According to the research, there are almost 70% of people in India who suffers from general disease, and 25% of people face death due to early ignorance. And the main reason for the ignorance can be a laziness to consult a doctor or no time for an appointment, which can lead to fatal disease. And that's where my objective of this project leads. The main objective is to build an effective disease prediction system by digging out some hidden knowledge from the patient's historical clinical data. And that's why I told the purpose of this search is to predict whether the patient is suffering from CKD or diabetes at an earlier stage. And there's where the significance is. As you know, one of the key components of successful healthcare organization is the ability to identify the disease with speed and accuracy. And the main significance here is to build a disease prediction system using machine learning to provide a better care and delivers quick guidance, even in the absence of human expertise, and that too in a very low cost. That's about and the significance of the study. And before all that, we'll definitely have to do a literature review on the present existing research. I have done a literature review on the existing system and the methodologies that they have used, and also summarize it into tables. So, you know, to better understand it. And we know there are know about machine learning, and it's a subfield of AI, and it's more accurate for predicting outcomes without being explicitly programmed. And we know there are different kinds of algorithms used. And here in this project, I'll be using classification that comes under supervised learning algorithm. Moving on to the literature review on the kidney disease. Here in the, I have gone through so many research papers, and I've cut down into 4 research paper here, and I've displayed it in a table format. You can see the algorithms that they have used, the accuracy that they have achieved, and the features selected, and the advantages and the limitations that I felt in that paper. So in the first paper, it says that potassium is one of the key features that they have used in order to detect whether the patient is suffering from CKD or not. I do agree potassium is one of the key importance, but that's not the only one. Here in that paper, they have again wonderfully written, and they have done the classification algorithms, and they have used the execution time. and they have used SVM and have scored 76% as the highest accuracy, and they have used all the features. Among all the literature study that I have found is one of the limitations that I found in this study is that they have limited the use of algorithms. So that's the gap that I found, and I've corrected it in my paper that you'll be able to see it. And in the second paper, he has stated that SVM classifier is more adequate for kidney disease because it deals with all type of data and it's flexible, allowed SVM to handle all the large features. I do agree, but in the conclusion of that paper stated that hyperparameters were not experimented and while evaluating their performance of machine learning. And in the fourth paper, author Udin has said that exploration of hyperparameters space can generate different accuracy and render to better performance of machine learning. So that's the literature study that I have done in the kidney disease. And in the diabetes, all the authors have used publicly available data set, which is PRIMA data set, which I have also used in my research. And in their framework, performing of prediction starts with the data set selections and the pre-processing. And once the data has been pre-processed, they have applied classification algorithms. Again, here they have limited the number of algorithms that they have used and did not state the reason for that. That's what I felt, and the highest accuracy that they have received is almost 86 to 89%. Again, to the existing system that is present in this world is that at an industrial scale, there are a lot of patients whose medical data are stored and result into a pile of data. And this data can be used in a good use through machine learning. And the data set present here in the used for prediction of disease that the patients have. Here's where machine learning comes into play, and that's why I've used as machine learning can help healthcare organizations to meet their growing medical demands and helps to improve the operations at a very low cost. Moving on to the research that I have made, there are two diseases. We'll be discussing about the kidney disease first, and then we'll moving to the diabetes. So kidney, is an essential organ in the human body, and there are approximately 1 million cases of CKD per year. And here I talk about renal failure. It is a dangerous disease in the kidney which produces a gradual loss in kidney failure if it is not detected at the earlier stages. Here, the data flow, I have made a web application in order to detect the presence of CKD. The data flow of that application is the user entering the inputs, and then it is being processed, and then it moves to the model and then predicts whether the presence or absence of CKD, and it is being displayed into the user interface which I made. Again, the system architecture follows the same basic 5 level of machine learning steps: pre-processing, going through the model, classification, correcting the model, predicting it, and getting the final model. In machine learning, data analysis also is very important. As I mentioned, the data set that I've collected for this study is over 2-month period in India with almost 25 features, and the data sets has almost data of 400 patients, and all the attributes are highly related to our target column, which is the classification. Here I have even counted the target column, which is fairly enough. It is balanced data set, and also have checked whether if there is any missing values. And of course, it's very important to check that, and that has been cured in the next step, which is data pre-processing. As I mentioned here in the data set, we have found some missing values, and that has been handled by adding some replacing it using FILNA method, which I've used, and I've replaced all the missing values with the key indicators of the trend, such as a mean, median, and mode. If the data is normally distributed, if it's not normally distributed, the mean of the numerical data was used to replace the missing values. So the next thing I have observed is there are categorical and numerical data. Numerical data I've kept as it is, and the categorical data has been converted to a numerical data using a label encoding method. We have a function in this sklearn to convert all the labels to numerical format. So all the categorical data are being converted into numerical data. Now our whole data set has a numerical format. Again, feature selection is also very important in the step, and Seaborn is a library which is great in visualizing the data set. Here I have found the correlation between each attribute present with our target column. So you can see we have given a cutoff range of 0.5. So in the last column, which is mentioned, which is the correlation between the target column with our all the attributes mentioned. We can see almost 9 attributes have been highly correlated. Again, a literature review of those 9 attributes have been also been selected. Therefore, we have selected 9 attributes from 23. We have divided the data set into testing and training data set. You can see 80% to the training and 20% to the data sets. And that's our pre-processing step in kidney. Moving on to the model building and their evaluations, as I mentioned, I've used all these 7 classification algorithms and I've put down into the confusion metrics. Here have been evaluated first. I've evaluated using confusion metrics. Here you can see decision tree and the random forest classifier has a tie between their values. Again, in order to know which is more accurate model, I've used classification accuracy. Which it's a ratio of correct predictions with the total number of predictions made. And in the graph, it is well clear that a random forest classifier was the best model for CKD. So that's the model which I have chosen for the model. Again, moving on to the diabetes. Here we know that almost in the year of 2019, almost 463 million adults ranging between 20 to 17 are detecting the presence of diabetes. And it's all been predicted that almost in 2045, 700 people will be having diabetes. So only method to avoid is early detection. Again, the data flow of the system remains the same. The user input and it's been processed and then pre-processed and getting the final model and being displaying it into our screen. Architecture also remains the same as I mentioned in CKD. Here again, dataset analysis for this. I have used Prima Indian dataset, which has almost 2,000 of instances and 9 highly correlated data attributes, which is being depicted in this data. Again, followed the same form. I have counted the target and it is fairly balanced. Again, here in the description of the data set is already given that the null values have been replaced with zeros. So you can see very few I have depicted in the graph so that you can see the data set contains few of the null values and everything is being pre-processed in the pre-processing stage. I have handled the missing values by replacing it with mean and median. You can see glucose and the blood pressure was replaced with mean and the rest everything was replaced with medium. That's how I handled the missing values there. Again, in the feature selection, I've used heat map to find the correlation between each feature with the target column. Again, it showed a fairly good enough result. And I've used SVM classifier, which is used to identify the main features in the classification. And I have eliminated insulin and blood pressure from the model. So that's how I selected the features. From that, so in total, we have almost 9 features. From that, we have selected 6 features, which is highly correlated with our target column. Again, the data set is converted to testing and training, 70% for the training and 30% for the testing. In the model evaluation, again, same method. We have we've gone through the confusion metrics first, and then we have got a good result in the random forest classifier. Again, in order to get more, just to be very careful, we have again used classification accuracy, which is the diabetes classifier. And it is clear that random forest, again, with 99.3% accuracy has scored the best model. So hence we found 2 models. which is used. And I would like to conclude by saying that both CKD and diabetes are one of the most serious illness today and needs to be properly diagnosed before turning into fatal disease. So with the help of machine learning algorithms, doctors could identify the illness at the right time. And this study finds the best algorithm for predicting CKD and diabetes. And I've used 9 different classifiers to check, and we have found that CKD with 99% accuracy and diabetes with 99.3% accuracy model. Again, for future for references, I've gone through so many papers that are already existing. And in the future enhancements, which I'm currently doing in my MSc, I'll be extending my research by finding the comparative study, especially in the execution time of the algorithm, and to find a few more feature selections model, and to have a comparative study with and without feature selection. Thank you. That's a good time. Thank you.
Thank you, Jimmy. Judges, do you have any questions for Jimmy?
Hi, Jimmy. I'm Praveen here. So I think it's timely. It's a really relevant research that you have done. So what's the training data set looks like? What's the size of the training data set?
70% of the data.
So how many data points do you have in total there?
In diabetes, we have almost 2,000 in total, so it will be around 1,500.
For diabetes, and for the other one?
For CKD, it will be almost, it was 400, so it will almost be 300 for training.
For in that 400 data set, how many independent variables did you have?
From that, we had all the data, which we had like almost 25 features, right? So in that, we had almost 15, if I remember.
Okay. For that model, don't you think it will result in a too much of a rigid model? So you have like 300 or so training data points, and then you have like 15 or so independent variables, and you will be using things like XGBoost models also. So don't you think it will result in a more rigid model? Don't you think so, Jimmy?
In very low percentage, because the model has been trained with the highly correlated value, and we have used feature selections that using heat map, right? So we have almost selected the features which are highly correlated with the target column. So that's the features that I've used.
Okay, so in the model, so you haven't used all those 15 independent variables?
No.
Okay. And also, Jimmy, have you thought about how you will be using, if you've gotten a chance to use this in a real world scenario, how have you thought about how this will be used?
Yes, so that was the main objective. So this data will be collected from the historical clinical data of each patient, right? So after every time the patient goes and checks his even he's not going and checking whether he has chronic kidney disease or diabetes. For some reason, even full body checkup, all these data has been already stored in the medical records. So those data are being passed through the models, and then we are reminding the patients that he will be having CKD in future. He has this much % of chance. So that's the main objective. We are using the historical clinical data for this.
Okay. That's all the questions I had.
Thanks, Jimmy. I have a couple of questions too. Can you describe the primary research you did with collecting the kidney data set? So that's the one you did in.
Sorry, sir.
that is the one that you collected in India, right?
Yeah.
Yeah. Can you tell me a little bit of the data collection process? Where did you do that? And then did you connect it with the doctor? Are there any support from them and so on and so on? I just wanted to understand like, how did you do that?
Okay, so it's available in the Kaggle and it's been certified by doctors, and it has been publicly available for all the researchers to get that data set.
So this is a Kaggle data set, is it?
Yeah.
Okay. I was thinking whether you have been to some rural place in India and connected with the doctors and you collected the data by yourself. Okay. Understood. So do you have any background on in terms of that particular data set? Like,
yes, sir. In the data set, it's already mentioned about the brief description of each and every attributes that they have used. And from that, they have selected 25 features and have kept in that data set, which are highly related to CKD. From that, I have done some pre-processing and the correlations to get 9 from that.
Okay. So especially your research is connected to the health domain. It's important that you connected with some of this expertise from this particular field, right? Especially the doctors, right? So let's say if I'm a doctor, so the main question for me is, why should I trust a computer? Right? Because I have the expertise that I can, go through someone else's history and then I can mention whether he has a disease type 1 or type 2 or type 3 or type 4, right? So did you had any connect with medical expertise to do this research?
In this research, no, sir, but definitely I'll be adding for my future enhancement this point, which I'm currently doing in my MSc.
Okay, so you are kind of planning to expand this research for MSc and where you can connect with some of the doctors in UAE to connect with the medical experts because okay, cool. Thank you. Understood. Good job. Thanks.
Thank you, sir. Thank you so much.
Thank you, Jimmy. So that marks the end of the QA session. So it's like very fascinating to see how machine learning can be applied in healthcare and like how we can benefit from that one. So let us move on to the sixth thesis presentation. So we have a reverse logistic network model for handling e-commerce returns by Pamal Nanayakkara. So he holds a BSc in Transport and Logistic Management from University of Moratuwa. He aims to identify return patterns of the customer markets and decide a better location to locate initial collection centers with the help of data analytics. So Pamal, can you please turn on your camera and state your name for an audio-visual check?
Hi, good morning. You can hear me, right?
Can hear. Yeah. Can you share your screen as well, please?
Sure.
Visible. So let me remind you the rules. So you will be getting 15 minutes to do your presentation, and at 14th minute I will be announcing saying like 1 minute left, and after that within 1 minute you have to conclude your presentation, and that will be followed by 5 minutes Q&A session with the judges. So let me start the timer. Yeah, so you can begin, Pamal. Good luck.
Thank you. Hi everyone, good morning. I'm Pamal Nanayakkara from Department of Transport and Logistics Management in the University of Moratuwa. My research supervisor is Dr. Amila Tippotuwal, and I'm here to present the research findings on the reverse logistics network model for handling e-commerce returns. E-commerce industry has been in the booming stage for years now. It is recorded in the period between 2014 to 2020, around 220% growth has been recorded in the e-commerce sales worldwide. With that, 30% or more have been product returns out of that sales. This indicates the criticality of returns management for an e-commerce firm to mitigate these issues. But unfortunately, most firms consider this as a unimportant factor and a burden to them rather than considering it as an important factor. But with the escalating reverse logistic costs as well as environmental concerns, customer awareness and legal pressure have led these firms to rethink and pay a great interest in designing the reverse logistics supply chain network. Reverse logistics refers to efficiently and effectively managing all the flows while considering the flow from the point of consumption to the point of origin. As an example, if not collected and treated properly, electronic and electrical products can end up in landfills, creating major environmental problems. It is mentioned that in the year 2019, e-waste amounted to 53.6 million metric tons was generated, and inside those e-waste, there were raw materials worth $57 billion. This is an example for linear economy, which is take, make, dispose. But currently, world is moving towards circular economy, which is sustainable at its production levels as well as user levels. With the circular economy, options such as recycle, remanufacture, refurbish, reuse comes into play, making world more green. Having narrowed down our research scope to find a way to handle e-commerce product returns under a circular economy, we explored existing literature. Here is the literature summary created out of many journals. So from this literature review, we found out there are no existing quantitative studies that addresses the combined research domains of reverse logistics, network design, e-commerce, circular economy, and Industry 4.0. So with those research gaps as well as other research gaps stated in the literature, we have formulated the following research questions. That is, how to categorize customer markets of the return products using Industry 4.0 technologies, how to utilize integrated decision making in managing reverse logistics of an e-commerce firm under a circular economy, how to adopt a circular reverse logistic network of an e-commerce firm considering sustainability. And along the way, we have formulated these research objectives to answer the above research questions. Those are identify best machine learning approach to categorize customer markets based on e-commerce product returns, and then conceptualize a circular network in a real world e-commerce setting to accelerate transition towards a circular economy. Then finally, develop a reverse logistic network design that would minimize the total cost. When referring to literature, we found out there are two basic approaches mainly used in supply chain network design. Those are, plainly speaking, with respect to our study, a direct approach will refer to here as a method where consider predetermined set of location to locate warehouses based on purely human judgment. And the stage-wise approach rather have a stage-wise execution, and they will identify the set of locations to locate warehouses as the first stage and then followed up by other stages. So considering the factors such as optimality of the network, circularity, applicability in a decision support tool, we chose stage-wise approach to be the most suitable research methodology for our study. So the stage-wise approach have 3 stages in this study. So we have compared what are the potential methods inside these stages. As the stage 1, we will be categorizing customer markers of the return products using machine learning. So we identified there are 3 widely used machine learning techniques in the existing literature. Those are k-means, hierarchical, and density based. Out of those clustering methods, we found out when considering scalability as well as applicability with all type of attributes and ability to mix parameters, which is key in this study, hierarchical clustering has the highest applicability to our study. When comparing the going into the stage 3, we identified there are several methods in mathematical modeling for supply chain network design, but most of the researchers have found out that using mixed integer linear programming is significantly important in a supply chain network design. So we have chose mixed integer linear programming to use as the methodology in that stage. what's actually happening inside our research. We are trying to introduce integrated collection centers. As an example, initial collection center, this will perform as, and to this integrated collection centers, after receiving the e-commerce product returns, utilizing integrated decision making, we will first inspect and sort, and then direct those return products to either resell, either remanufacture or recycle. So how can we identify where to locate these integrated collection centers so that we can embrace circular economy in our operations? That comes up with these 3 stages. As the first stage, we will be implementing hierarchical clustering with geographical constraints. This is a novel method we have developed, especially addressing the e-commerce settings, and we have utilized data such as volume of returns, frequency, and price of returns inside the clustering. Then moving on to circular economy network in e-commerce reverse logistic network, we will be establishing this circular economy network so that we can utilize circular economy in our network. After using this circular economy network, then we will be implementing mathematical model formulation using mixed integer linear programming, taking the above mentioned circular economy network as our network. So this mathematical model formulation will assist us in optimizing the total reverse logistic network. So we based this study on a case study, and it is based on a Brazilian e-commerce firm. And we obtained the data from a publicly available dataset from Kaggle, and then taking necessary assumptions, we finally derived at the target dataset, considering only electrical and electronic products out of those e-commerce product returns. So moving on to stage-wise approach, here we implemented the hierarchical clustering with geographical constraints as the first stage. In the first dissimilarity matrix, we will use volume of returns, frequency, price of returns as the parameters inside the first dissimilarity matrix. Then we will introduce geographical constraints. While doing so, we will use a mixing parameter called alpha to obtain geographically compacted clusters. Here we have used an alpha value around 0.7 and then obtain the final hierarchical clustering with these customer cities in Brazil. And we use RStudio as well as ClustGeo package to obtain these clusters. Then moving into conceptualizing circular economy network, as we mentioned that from customer markets, e-commerce product returns will be returned to our integrated collection center. There, using integrated decision making, using the ICT-enabled communication between sellers and formal recyclers, we will establish a communication network. Then, if we want to resell, we have decided to resell, we can direct these products into our fulfillment centers, or else if these products are going to repair, refurbish, and remanufacture, sellers can come into our integrated collection centers in their forward logistics and bring the return products to their firms and do the operations. If we decide to recycle, we can direct these products into formal recyclers. And this is the mathematical model we have formulated. These are the sets parameters. And inside this mathematical model, there are decision variables such as if this particular ICC is to be opened or not, and if customer index allocated to ICC, the allocation is done to the particular ICC or not, and then the quantities of the shipments that would be sending out to fulfillment center and formal recycling center from our integrated collection center. And in particularly these integrated collection centers that would be input to this mathematical model would be the cluster centers that we obtain from hierarchical clustering with geographical constraint. Inside this mathematical model, we have cost components such as fixed cost, transportation costs, as well as inventory holding costs. So these are the constraints that this model applied to. And then we used IBM iLog Ciplex optimization studio software to find out the optimum solution to this MILP problem. So while opting out to open 3 ICCs out of the 4 that we inputted. Three-stage approach has derived the lowest optimum cost per annum over direct approach. And you can see in the right-hand side, the ICC selections that was proposed under this three-stage approach. We also could deeply get the insights on how much each cost component contributed to our total reverse logistic cost. It is indicated in this bar chart. So moving on, then we tried to test the validity of our model, varying three ways in parameters inside this model in 3 ways. As the first stage, we have varied returns volume. And when you can observe when varying returns volume from percentages wise, still three-stage approach gave us the lower cost while showing growth is steadier and lower overall compared to direct approach. This is same can be mentioned applicable to the each cost component in this total reverse logistic cost, which is denoted under that right-hand graph. And most importantly, e-commerce firms can obtain 40% cost savings when they implement three-stage approach over direct approach, even when facing up with almost these returns volume variations. That's a key finding for an e-commerce firm to save their costs. Then we varied the number of ICCs because an e-commerce firm should have the flexibility to opt for any number of ICCs. Given they face human capital restrictions, financial restrictions, they should have the ability to choose, no, I am not going with the optimal solution, but I would go along with any other number of the ICCs. So here we have varied the ICCs from 1 in both positive and negative sections and showed what are the cost savings they could obtain as well as total cost components when varying the number of ICCs. And then finally we varied both volume, returns volume as well as number of ICCs together. In particularly, if you see the box plot chart, you can understand that when observing the height of box plots as well as their positions, three-stage approach always have given stable solutions for every ICC selection with comparatively lower cost ranges when returns volumes increase. So this is again testify that our model is a significant finding for an e-commerce firm with their flexibility in decision making as well as to take correct decisions accurately. And then in the right-hand side graph, you can see if decision makers in e-commerce firm try to understand what is the cost distribution with respect to returns volume when selecting particular number of ICCs, this is the thing. And do you want to, if you are e-commerce firm manager, do you want to embrace circular economy? Or do you want to have a systematic approach to it? And while doing so, do you want to take cost saving decisions and optimize your reverse logistic network? We have covered you with the decision support system by using inputs, process, and particular desired outputs in all these stages. You can finally fulfill your dream of becoming an e-commerce firm who performs, enables circular economy in your operation and be a responsible firm. And this is the graphical abstract. We are trying to identify where to locate integrated collection centers, and we have proposed a framework to do so in a systematic manner, and then we can obtain optimal ICC locating and 40% cost saving. We have done some research publication using this research, and that's all for this presentation, and thank you very much.
Your time is up. Judges, do you have any questions for Pamal?
Hi, Pamal. I'm Praveen here.
Hi.
So I think you've put together the technical components of it, and then you've looked a lot of how it will affect the businesses and all. And that's why I really like your research. So can you go back to your the optimization problem that you had in your
Sure.
So you are minimizing what are you minimizing here? The cost.
I'm minimizing the total reverse logistic cost, and that total reverse logistic cost is compromised from fixed cost. That is fixed cost for locating and maintaining integrated collection centers, and then transportation cost components. We have to transport the return products from customer markets to our integrated collection center. And then inventory holding cost, we have to hold our inventory while taking the decisions and sending out to particular parties. Then transportation cost from our integrated collection centers to fulfillment centers if we decide to resell these products. And the transportation cost from ICTs to formal recycle centers if we decide to, no, we can't use this return product, it's not under good state, so we have to recycle this. These are the cost components in this total reverse logistic cost.
Okay, so you have only the costs, right? Okay.
Yeah.
It it takes a bit of time to go through everything, but okay. Yeah, that's all the questions I have.
Thank you.
Thanks, Praveen. Hi, Pamal. So I'm Rajitha here. So I have a couple of questions and nice presentation. I was kind of enjoying that, how you have bringing the mathematical concepts for research. I just have a couple of questions. I wanted to understand, are there any like a similar systems available? What is the state of the art?
So state of the art, this is a novel contribution. Why we are saying novel contribution? We found out there are very few limited studies to identify how to design an e-commerce reverse logistic network. There are many parties who engage in other supply chain network, but the thing is with e-commerce, we have product returns. So when capturing this aspect, this is the first time that this kind of a systematic manner research contribution is happening. Others in the state of art in the literature, what they have used is that particular direct methods. That is mean we think, okay, we from the business judgment, we think we need to locate our integrated collection centers in Colombo, Gampaha, and somewhere likewise. But that's a pure human judgment. Then only afterwards they have developed all these network designing concepts. But we thought there was a research gap stated by quite recently. They mentioned that those parameters have to be undertaken to consideration to identify where to locate these integrated collection centers in a systematic manner. That's why we are proposing to use this hierarchical clustering with geographical constraints, then go into circular economy network. This is again a novel contribution because circular economy network is a very, very untouched concept because there should be connectivity with both parties, but many existing state of art literature only goes on a kind of a theoretical manner, but they don't go into application of a real world e-commerce setting. That's why this study have this kind of 3 stages to obtain final answers.
And what is the time complexity for this optimization?
So the optimization for the IBM Cplex didn't take much time. It actually take IBM iLook Cplex Optimization Studio. This took like around 5 minutes to give the answers when varying with all these elements.
Okay. So what is your next steps, Pamal?
So as the next steps, currently, as we mentioned, we took portions of these studies because this is a big research study. We have submitted to several journals and waiting their positive response. And there won't be any extensions from this study, but I would like to study more on how to enable these circular economy networks and try to minimize the barriers if there's in a real world setting and do another parallel study along the way.
Okay, cool. Thank you, Pamal. Thank you. Good job.
Thank you very much.
Thank you, Pamal. So that's that marks the end of the QA session. Yeah. So again, I think it's very interesting to see how different domain benefits differently with the emerging with this machine learning technologies. So before moving into the next presentation, I would like to introduce two judges who are from OCTAVE again. So we have Dinusha Dissanayake, who is currently working as a data scientist in the beverage stream. She earned her BSc and MSc from University of Perera, and her areas of expertise are machine learning and statistics. And then we have Thiraj Silva, who is currently working as a data scientist in leisure and hospitality stream, and he earned his BSc and MSc from the University of Technology, Sydney, Australia. And his areas of expertise are data analytics, machine learning, and in domains such as insurance, retail, and leisure and hospitality. So yeah, without further ado, let's move into the seventh thesis presentation. So we have customer segmentation system by team relevant analytics. So we have Arun Prashant Shanmuganathan and Sandhuni Dayanand from University of Jaffna. They hold a BSc in engineering specialized in computer engineering. The aim of this presentation is to try out popular machine learning models to do customer segmentation. So Arun, Prashant and Sandhuni, can you please turn on your cameras and state your name for an audio visual check?
Hi, good morning, everyone.
Good morning. Arun, Prashant, can you also state your name so we can check the audio? We can't hear you, Arun. Are you on mute, Arun? Because we can't hear you. Okay, I think that.
Yeah.
Okay. Can you share your screen as well? Yeah, I think all good. So let me remind you the rules again. So you will be getting 15 minutes to do your presentation, and at the 14th minute, I'll be announcing that you have 1 minute left. So within that 1 minute, you have to conclude your presentation. So then it will be followed by a 5-minute Q&A session with our judges. Okay, yeah. I'll start the timer and I'll let you know once I do that, and you can start your presentation. Okay. Yeah, you can start your presentation.
Yeah. Good morning, everyone. Our final year research project is about a customer segmentation system. Go to the next slide. Arun, can you move to the next slide? Yeah, this is related to a retail store, and mostly on Fridays. So this is our. Yeah, mostly on Fridays, the men who are in between 30 to 40 years are most likely to buy baby diapers and also beers. So if the beer aisle and the diaper aisle keep closer to each other, it will give an amazing result. So it increases 35% in sales for both diapers and beers. So that is a quick fact about our project. Let's dive into it. Move to the next slide. So this is the agenda for our today's presentation, and move to the next slide. Next slide. Arun?
Yeah, I'm already
in today's world, there are there's a big competition between most of the business related companies, and the most important thing is we need to have a clear understanding about the customers' needs and wants and their bases. So simply, the customer segmentation system is the process of dividing customers into distinct, meaningful and homogeneous subgroups based on their attributes and characteristics. And of course, definitely this study will help to identify the new market opportunities and the potential customer bases. And move to the next slide. So our aim is to improve the business marketing strategies and campaigns, and our objective is to eventually investigate and compare the segmentation models for a business by using the customer's transaction data, and the final deliverable will be the decisions based on the results of the segmentation models. Next slide. Yeah. In respect to the research scope, I would say that we selected a relatively larger data set, so it helps us to get the more accurate segmentation results. And we have used LRFMP score and unsupervised feature selection methods. So we'll later on in detail, we'll discuss about these methods. So next slide. It's getting late to move to the slide. So about the data set, we got our data set from the Starbucks. And this is related to 1 month transaction data of 17,000 customer profiles, and it has around 306,000 transaction details. And the data set includes around 3 data files. One is customer profile. This includes the data about the customers, like their age, gender, and all that. And the other one is portfolio. This includes the details about the offers, like offers sent via web, email, mobile, or all about that. And the last file is transcript. This includes the data about the transaction and the offer interaction details. And next slide. And moving on to the methodology, first we got a brief understanding about the business and the design of the segmentation process, and then we got clear understanding about the data set, and we did pre-processing and data enrichment, and then we identified the segments, and after that we evaluate the profiling of the segments, and finally we deploy the segmentation solutions and the design. Move on to the next slide. So we referred many research articles from the initiation to the end of the project. So we pick 2 of them. So one is related to principal component analysis. You know, PCA is kind of a technique we basically use for dimensional reduction, and also it helps to minimize the information as well. So the goals of using this technique includes it helps to compress the size of the data, it helps to simplify the description of the data, and analyze the structure of the observations and the variables. Next slide. And the second article is about a survey on feature selection method. You know, there are many feature selection method like filter, wrapper, embedded, but this feature selection method has a limited scope in unsupervised learning, and this feature selection method helps to reduce the computation time, and it helps to improve the performance and all that. Move to the next slide. LRFMP score. Here the L indicates the length, and R recency, F frequency, M monetary, and P indicates the periodicity. Here the length means time interval in days between the customer's first and last visits, and the recency means average number of days between the dates of the customer's recent visits, and the frequency means the number of purchases within a certain amount of time. Move on to the next slide. Monetary indicates the amount of money for spent for a particular transaction, and the periodicity is the standard deviation of the customer's inter-visit times. Go to the next slide. Yeah, this is one of the screenshots we got from our implementation. So this is related to a particular customer. Here you can see he has completed 3 transactions. So according to these details, we calculated the LRFMP score. Here he has completed 3 transactions, so his frequency is 3. Likewise, we calculate the length, recency, and periodicity for all of the customers. Move on to the next slide. Next slide, please. Yeah. Evaluating a clustering algorithm is a bit tricky, because why I am saying that is because we don't have exact matrices to evaluate them like in the supervised learning algorithms. So we selected two important factors. First one is number of clusters. This indicates the K. So if the K is high, that means each data point is broadly start representing a cluster, and if the K is 2 means then there's a possibility to incorrectly cluster the points. And the other important factor is clustering quality. If the distance between the two clusters, to improve the clustering quality, we should maximize the distance between two clusters, and also we should minimize the distance between two data points in a particular cluster. Go to the next slide. Yeah, we have implemented 3 models: K-means, DB scans, fuzzy C-means, and Gaussian mixture models, and we calculated 2 scores: Seelholt score and Kalinski-Harabas score. So by looking at these scores, you can see we got higher scores for K-means and fuzzy C-means models. So we come up to a conclusion about that. We got higher scores for K-means and fuzzy C-means than the other 2 models, and we identified that from the both of models, the optimum number of clusters for these two models is 2. Yeah, Arun, over to you.
So moving on. So what we thought to do was analyze any unsupervised feature learning methods here. There have been many methods mentioned in the supervised learning algorithm, but it's pretty rare in the unsupervised learning. So one of the method is the principal feature analysis. This has been used in face tracking and content-based image retrieval, and also in brain decoding using functional magnetic resonance imaging. So this can be used as an unsupervised feature method. And when comparing with the PCA, a PCA is not a feature selection method. It is merely a dimensionality reduction method. What PCA does is it transforms the original feature set into a subset of interrelated transform sets. That's what PCA does. But unlike the PCA, what PSA does is it selects a subset of preliminary features, which means it can be used as a feature extraction method in unsupervised learning algorithms. So that's what has been said here. And we'll see how this principal feature analysis works. The algorithm for this can be summarized in 5 steps. And the first 2 steps are similar to how PCA is computed. The first step is obviously computing the sample covariance matrix and computing the principal components and eigenvalues of the covariance. That's how PCA is also computed. But what happens here is in the next step is a subspace dimension Q is selected. That can be selected according to according to the number of features that we wish to retrieve. So when after selecting that Q, the matrix AQ is constructed, and after that, these clusters will be clustered into P clusters. P will be the number of features, and after to cluster this, we can use K-means or anything like that. And after clustering, using any distance measuring measurements like Euclidean distance or something like that, we can find the corresponding vector which is closest to the mean of the cluster. By that, we can select the number of features that we have defined at the initial point in the project. So from this, we will be able to extract the number of features that we wish to retrieve. So here we can see a comparison between the PCA and PSA. We have mentioned the course here, and we can see here with PSA the model performs largely better without rather than using the PSA. We can see the PCA gives good results for good results when the number of cluster is 2. The results are better, 0.25 and 0.23 in range of that there are results. What PSA does is it also improves the results for the number of clusters when it's equal to 2, and also improves the clustering validity for other number of clusters as well. That means when the clustering number is 3 or 4 or 5, then also it provides a better result, which PCA clearly doesn't. So, and also we can see that the best results is obtained when the number of features is 6 and the number of clusters is 2. That was the best results obtained. So after finishing the clustering process, it must be evaluated, and to evaluate we have used the parallel coordinate plot and the SNS pair plot. Here in the parallel coordinates plot we can see that for the segment, the first segment, the orange segment has low values here for these columns, which are the number of sum of offer received, the offers completed, and the offer viewed. Likewise, those have low values. Likewise, the mean reward obtained by completing the offers, and the mean difficulty and the duration, and the completed discount, and those things also have low values. But the period
have 1 minute left.
Has here we can see the opposite for that next segment. So analyzing the segments, here we have selected a few criteria for both the segments and the joinments. Or by seeing and analyzing all these, we can see tell that the segment A contains mostly newly joined customers, and they have low offer completion rate, and they have completed offers with lower difficulty, and they are interested in the buy one get one offers but doesn't act on it regularly, and they are low on spending value as well. So the segment B consists of mostly loyal customers with regular interval visits, and they have good conversion in all the offers, and their spending value is average and moderate when comparing with the segment A. So that is what the results that we have found from the our segment, and these are the reference that we are using.
Thank you, Arun, Prashant, and Sandhini. So judges, do you have any questions for the team relevant analytics?
Hi, Thiraj here. So interesting fact you mentioned in your first slide with the baby diapers and the BS. I just wanted to know how you all determined the number of clusters for your k-means. Like, how did you determine the optimal number of clusters?
For each of the clustering algorithms, we used for the k-means, we used the elbow plot. Likewise, for the DB scans, we used the minimum number of the points to be in a cluster. Likewise, we used the techniques that are referred in the papers to find the optimal number for each of the algorithms.
Understood. And also regarding the two segments, segment A and segment B, do you have the feature distribution among the two segments by any chance?
Sorry, not included in this slide.
That's okay. That's okay. Yeah. Dinusha, you have it?
Yeah, hi guys. So actually great presentation, very well organized, and the framework is very well outlined actually. I have just two questions. How many features did you have in the overall data set?
after applying the pre-processing and all, there were 28 features.
No, before applying the this feature selection principal component analysis, that is 26.
Yeah, from the data set that we obtained, that you asking.
Okay, then why did you thought of using this feature selection and principal component analysis?
Yeah, the thing is, first we applied the clustering algorithms without using the PCA. But the results with the PCA was better in the baseline model. The results with the PCA was better than rather than without using the PCA. So we thought the PCA is playing a part in improving the clustering quality, and we thought, is there any way to make that better? So we thought about analyzing into the unsupervised feature selection method, which is pretty rare. And we were able to come up with PFA, which was used mainly in the image segmentation and context-based image retrieval.
Okay, got it. And only one more question. That is, you guys use this k-means, DB scans, clustering algorithms, right? So were you maybe researching ways to make it faster, or did you think the performance is okay?
The performance was okay. We didn't actually work on improving the runtime or performance, since the runtime was fairly small.
Okay, okay, got it. Thanks, Arun. Anurangi, that will be all.
Okay, thank you, judges. So that marks the end of the QA session. So I think, again, it's a very interesting research area that even very much related to the domains that we are working. So far, so we have witnessed 7 equally interesting presentations addressing a different domain. So I know for a fact that it's not going to be an easy task for the judges to select a winner. So we have 3 more interesting research presentations remaining. So let's move into the next presentation, the 8th presentation. So it's a study on the influence of international trade, monetary policy, and regime shift towards economic growth in Sri Lanka by Rashmi, and she holds BSc Honours in Industrial Statistics from University of Colombo. Again, this research addresses a timely topic as it focuses on finding the influence in international trade, monetary policies, this kind of stuff towards economic growth of Sri Lanka, which is crucial at the moment. So Ruwani, can you please turn on your camera and state your name for an audio visual check? Okay, can you share your screen as well, please? Okay, so let me remind you the rules again, Ruwani. So you will be getting 15 minutes for your presentation, and at the 14th minute, I will be announcing that you have 1 minute left. So you have to conclude your presentation within that 1 minute, and it will be followed by 5 minutes Q&A session with the judges. Okay, I'll start the I'll start the timer now, so you can start. Yeah, go ahead. Good luck, Ruwani.
Hi everyone. I'm Gunawardena, representing University of Colombo, and my final year research is on a study on the influence of international trade, monetary policy, and regime shift towards the economic growth. It was done under the supervision of Sarmilan. Throughout the presentation, I'll give you a brief introduction on my research, and then the objectives and the significance of the study, followed by the methodology that I followed and also the significant findings. Last but not least, it's about the discussion and the conclusion. First of all, I'll brief you guys on the main terms that's associated with the research. So firstly, it's international trade. So what international trade means is it's a basic economic concept that involves buying and selling, or rather exchange of goods and services between countries. So there are 2 main components that comes under that. That's exports and imports. So when it comes to monetary policy, it's a tool that is used by the central banks of countries to promote sustainable economic growth so that they can sustain the money supply of a country. So it's associated with the expansion or contraction of the economies. And then it's a highly discussed topic these days also. It's a regime shift. And I've considered the government change of Sri Lanka under this variable. So with that, I've checked the economic growth fluctuation in Sri Lanka using the GDP variable. So economic growth refers to the increase in the inflation-adjusted market value of the goods and services produced by a particular country's economy over time. So, discussing about the background of the study, with the COVID-19 that took place since 2020, we all know that the global economy has shrunk, and even the IMF, that is the International Monetary Fund, states that the global economy has shrunk by 4.4% in 2020, and it has led majority of countries to a recession. And also when it comes to the Sri Lankan economy, as a nation that suffered from around like 70.8% of fall in tourism due to the East attack also that took place back in 2019. The annual report published by the central bank in 2020 says that the GDP has declined by 3.6% itself. So rebuilding the declined economy in Sri Lanka has been a highly discussed topic, and it's a crucial factor now. So I thought of studying this topic. On with the objectives of my study. The primary objective of the study is to identify the influence of international trade, monetary policy, and regime shift jointly towards the economic growth in Sri Lanka. Also, it's followed by some secondary objectives as well. That's to identify the most important factors associated with this economic growth in Sri Lanka, and also to develop suitable econometric models as well as machine learning and deep learning models. And then also to compare the performance measures of these models and to come up with the best model such that we can use it in forecasting the economic growth in Sri Lanka. So when talking about the significance of this study, as I mentioned earlier also, with the prevailing COVID-19 pandemic situation in the whole world, uplifting this declined economy has been one of the main things, most discussed topics now. So we had to pay more attention to international trade-related variables, and how to improve them. Also, no research has been conducted yet to find the exact quantitative relationships among the international trade, monetary policy, and regime shift jointly, like how they affect jointly towards economic growth. Many researchers are there to calculate the individual impacts of those three variables, even in Sri Lankan literature, but they have not been done any joint researchers to check the joint impact. So this would be a unique research in that case. So this can be used to give the suggestions for further improvements as well for the policies, and for the improvements as well as we can impose, the policymakers and the relevant authorities can impose relevant policies, the new policies as well. So since I developed some machine learning approaches models as well, they can be used in as a proactive measure. Now I'll discuss the methodology that I followed in brief. So it has four main components mainly. That's data preparation, data pre-processing, descriptive analysis, and the advanced analysis. So when it comes to the data preparation, it included the decision on the variables to include in my research, and then data entry as well as rebasement and conversion of the variables. So these are the variables that I included in my study, and I obtained the variables, the economic data from the Central Bank of Sri Lanka website, as well as the regime shift variable, which represents the government change that was obtained from the Parliament of Sri Lanka website. So the data set consists of monthly observations from 2007 January to 2021 July. So the initial data set included 175 observations. So when it comes to the data preparation, it's mainly about the GDP variable, which is the response variable. So since GDP variable was available in 2 base years, 2002 and 2010, it was initially rebased to 2010, which is the latest base year. And then since it's available in quarterly values, I used cubic spline interpolation in RStudio by using the deployer and zoo package to convert the quarterly GDP values to monthly values. And then it's about data pre-processing. So this mainly includes the missing value imputation. There were missing values in interest rates and government expenditure. So last observation carried forward method was used to impute missing values in interest rates. And the government expenditure, the missing values in government expenditure were imputed using the impute TS library in R. So then comes the descriptive analysis. So this was done using Python, and I analyzed the univariate. I did the univariate analysis on the continuous time series variables and the bivariate analysis on the categorical variables such as regime. So this is the GDP, the gross domestic product, which is a response variable. This is a univariate plot of that. So as you can see here, we can see the significant decline in the economy that took place due to the effect of COVID-19 back in 2020. Also, the response variable was measured in rupees million. Then comes the advanced analysis. So this includes developing econometric models as well as machine learning and deep learning models. So under the advanced analysis, the first step was to check for stationarity, because this study includes time series data. So checking for stationarity is a vital thing when dealing with time series data. So what is stationarity? The stationarity is the statistical the statistical properties of a time series do not change over time. That is, the mean, variance, and the covariance has to be constant. So what makes the time series non-stationary? That is if the time series contains a unit seasonal or a non-seasonal unit root, the series is said to be non-stationary. So I tested the stationarity of the time series using ADF test and HES test, and treated accordingly prior to applying the variables to the models. So after that, I developed the econometric models. So as an initial model, I developed the univariate model Sarima. First, I included all the time points, all 175 observations. That data set included COVID-19 impacted data. But after the accuracies the performance measures was checked, the performance was very low due to the COVID-19 data not being in the training data set. So with that issue, I had to remove the COVID-19 impacted data, that is from 2020 January to 2021 July. Those data, the data relevant to that period was removed. After that, I applied the data on the Sarima model, and it gave a better accuracy, but then the residual diagnostics showed that the error terms are correlated. So to treat that issue, I transformed the GDP variable, log transformed the GDP variable, and then applied it on the Sarima model. It gave around a 98% accuracy, which is a good value. So after that, in order to improve the GDP forecasting with to check the improvement with the other independent variables, I applied the VAX model, which is a multivariate time series model. And it gave an accuracy of 99.94%, which is a good value. But here also, the error terms were autocorrelation existed among the error terms. So the model is not suitable for forecasting, but it's a good model to in the scenario of predictions during the concerned period. The model could not be developed further because of the lack of data points. Also, then I moved on with developing machine learning models. Under this, I developed random forest model, XGBoost model, and multivariate LSTM model, which is a deep learning model. Also, I applied feature selection on random forest and XGBoost model and developed all the models using the important features. So this represents the summary of all the models that I developed. As I discussed, the LSTM model with random forest selected features gave the best accuracy in terms of all the performance measures, RMSE, MAPE, and R-squared. So it can be used as the best model to forecast the GDP in Sri Lanka with the use of all other independent variables. Then comes the significant findings of the study. So the most important thing is that I could observe that random forest and XGBoost models from the variable importance plot of the machine learning models. It was observed that consumer goods, intermediate goods, and inflation, also the trade openness index, plays a major role in the significant role in economic growth in Sri Lanka. And the impact of regime shift is not that significant. So that is also a very significant finding of my research. Then comes a discussion. So as I mentioned above, in order to build the declined economy in Sri Lanka, policymakers and the respective authorities should pay more attention on the exports and imports, that is mainly the consumer goods and intermediate goods, and also the other macroeconomic variables such as inflation and trade openness index. And then even though that we think that the regime has a significant impact on the decline or the economic growth of a country, I could find out that the regime is not that important. So we should not rely on the regime. It's important to pay more attention on the import and export share of GDP with regards to consumer goods and intermediate goods. As an example, since we already know, like under intermediate goods, it comes the fertilizer and the fuel. So under consumer goods, it's mainly about food and beverages. So it's very crucial to, it's very important to pay more attention on that. So it's very it's the main finding also in this research. And also since the machine learning algorithms, if we can use the machine learning, if we can improve the machine learning algorithms further, it can be used as a great model to forecast the GDP, and we can use it as a proactive measure to help with the help rebuild the declined economy. Then comes the limitations of the study. The first one is
1 minute left, Roni.
Okay. So mainly the main limitation of the study is the lack of data points in the data set. As I discussed earlier, it was initially 175, but since I had to remove the COVID impacted data, it was 156. So therefore, I had to face an unavoidable information bias in that case, which has been added to the study due to the insufficient number of observations. So then comes the conclusion. So as I discussed earlier, it's the international trade-related variables such as consumer goods and intermediate goods, and also the macroeconomic variables, inflation and trade openness, have significant impact. So we have to pay more attention on that. And the regime shift or the expansion or contraction of the economy does not matter. That we should not rely on that. It's less significant. So the policymakers should pay more attention on the above discussed variables more. So in forecasting purposes, the LSTM model with random forest selected features would give the best GDP forecast because it has the best performance measures. And if we need if we need a better interpretable model, GDP predictions within the period 2007 to 2019 can be done by the Wijesinghe model. That's it about my presentation. Thank you all for listening.
Judges, do we have any questions for Runi?
Hi, Roni. I'm Dinusha here. It is very relevant topic, and you mentioned all the gaps and all very well mentioned. I just have two questions. One is, did you use any, so you said you, at the end, you have fitted random forest and SG boost models, right? Did you do any hyperparameter tuning there?
Yes.
Okay. Which parameters did you tune?
Minimum child weight and then minimum leaf nodes, such those type of parameters were tuned under both random forest and XGBoost.
Okay, well, only one more question from me. So as to evaluate between models, I saw that you have used accuracy as the metric, right? Did you look at any other metrics?
It was mainly concerning the MAPE value, that is the mean absolute percentage error value.
Okay.
Yeah, that's the main measure that I used to compare the accuracies.
Okay, right. Okay, thank you. That's it from me, Thiraj.
Yeah, thanks, Dinusha. So hi, Rooney, this is Thiraj here. Really interesting research. I believe your conclusion might stand true as well, given the current situation. Just a couple of questions also from me in terms of the number of data points, right? I know it's around 175, which went down to 156 data points. So how did you manage that when you're building a machine learning model? Like, what are the challenges you face and how did you overcome that?
That was one of the, that was the main issue that I had to face, the problem that I encountered throughout my research. So when it comes to machine learning algorithms, I could run the models properly, but I think I believe that the models could be improved if I can get some more data, but it's not possible right now. Yes.
Yes. Also, can you elaborate a little bit on the features you used in terms of the two data sources you retrieved it from?
So from the Central Bank of Sri Lanka website, I obtained the economic data. That's that's the variables related to imports, exports. So under that, there are 4 subcategories that comes under exports and imports, such as agricultural exports, intermediate industrial exports, consumer goods as the imports likewise. And then the inflation, government expenditure, so and so, that those variables comes under the economic data. So under the regime shift, I considered the government change. So that was those data were obtained using the Parliament of Sri Lanka website.
Understood. Yeah, clear on my side. Akhil, over to you.
Thank you, Ruvani. So I think it's a really interesting research, since at the moment we are as a country we are facing a very difficult time, so very relevant for the moment. So we can move on to the 9th presentation. So we have Sinhala hate speech detection in social media using machine learning and deep learning by W. Sivanesasuntharam Fernando. She holds a BSc Honours in Statistics and Computer Science from University of Colombo. So in her research, she provides a framework to automatically recognize Sinhala hate speech speeches broadcasted on social media. Sivami, can you please state your name to go for an audio-visual check?
Hi everyone, I'm Simi Fernando.
Okay, can you, you have shared your screen as well, so it's visible. So let me remind you the rules, Sumi. So you will be getting 15 minutes, and at the 14th minute, I will be announcing that you have 1 minute left, and you have to conclude your presentation within that 1 minute. And after that, there will be a Q&A session with the judges for 5 minutes. Okay, so I will start the timer now, and once I said start, you can start. Okay, you can start soon. Good luck.
Hi everyone, I'm Semi Fernando from University of Colombo. My research topic is Sinhala hate speech detection in social media using machine learning and deep learning. In this presentation, I will discuss about introduction, objectives, significance of this study, research process, data pre-processing steps, feature extraction and classification methods, then best 6 models, model performances on test set, conclusions, limitations, and future bugs. Nowadays, the internet-based communication media has become the most popular information communication technologies in every country. 3.96 billion people use social media worldwide in 2021. And 7.9 million social media users in Sri Lanka in January 2021. People can use social media to freely express their thoughts, options, and beliefs. Also, this platform useful to sharing information and updating information around the world. But there are some challenges. Some people are using this platform to spread hateful content, which leads to hate crimes. According to recent surveys, the rise in online speech content has resulted in hate crimes, including Trump's election in the US. According to article in ipsa.org, they said that disinformation and the spread of hate speech on Facebook in 2018 and 2019 following the Easter bombing led to anti-Muslim riots in Kandy and Negombo. So the hasty growth of race hate speech on social media seems to have big impact on racism, psychological and sexual harassment in society, and a big impact on goodwill of a country. To tackle this harmful hate reaction of hate speech, some social media companies, including Facebook, Google, and Twitter, they're getting faster at responding hate speech online. Those tech companies removed 72% of illegal hate speech on their platforms during 2018. But in Sri Lanka, current tool fails to detect of hate speeches and offensive languages on posts and comments since they were in Sinhala language. The manual process to identify and remove hate speech content is time-consuming and labor-intensive. When we move on to the objectives in this study, main objective is to classify social media content as hate speech or not by using different feature engineering techniques, machine learning, and deep learning algorithms. Then identification of different types of hate speech detection techniques and to analyze the performance of these tasks using different data sets. Hate speech has been a major concern on social media in recent years. Identifying hate speech and taking action against it is essential. These are the significance of this study. The ability to flag racist or sexist hate speech in social media will alert social media users to potential perpetrators. Such an ability will also empower potential victims to make them feel safer online. Let's move on to the research process. I use 2 pre-collected training datasets of different sizes. First, I conducted pre-processing steps, then used different feature extraction and classification methods. Afterwards, evaluated the model performances. After that, using model accuracy and F1 score, I selected the best 3 performed models for each dataset. It is essential to test model performances using a completely different dataset. Therefore, Facebook comments were collected using Instant Data Scrapper tool and manually annotated observations as hate or neutral by a majority vote of 3 independent raters. After that, I tuned hyperparameters in selected best 6 models and evaluated test set performances. Then selected the best model for single hate speech detection. These are the 3 datasets used in this study. Dataset 1 and dataset 2 are the training datasets, and dataset 3 is the testing dataset which I collected. Dataset 1 contains around 54% neutral speeches and around 46% hate speeches. Dataset 2 contains 45% neutral speeches and 55% hate speeches. When we move on to the data preprocessing steps, first removed non-Sinhala characters using regex function, since Sinhala Unicode posts were used to train the models. Then under the remove special characters, I removed numbers and punctuation marks. Then tokenized the comments and word frequencies were observed in descending order. Afterwards, removed stop words that do not influence the comments, being hate or not. The words like me, eka, wage belongs to stop words. By removing stop words, the dimensionality of the feature vector can be reduced. Finally, the stemming part was done. Stemming is the process of eliminating prefixes and suffixes from words in order to reduce them to basic words. Stemming also reduces the dimensionality of feature vector. These are the word frequencies plot for before preprocessing and after preprocessing. Here you can clearly see that full stop and commas were removed in after preprocessing steps. When consider the word Lankavatta in stemming part, it reduced to the basic word, which is the Lanka. Then I used bag of words, TF-IDF, word2vec, fastest as feature extraction methods. Then used these machine learning models, including logistic regression, support vector machine, multinomial naive Bayes, random forest, and XGBoost. Then CNN, RNN, LSTM, deep learning models were used. In research process, I mentioned that I have selected 3 best models from each training set. So these are the best 6 models from for the first data set, which contains a small number of observations. Multinomial naive Bayes, support vector machine, and random forest performed well. And for the second data set, which has a large amount of observations, logistic regression, support vector machine, and recurrent neural network performed well. Then hyperparameter tuning is an essential part of controlling the behavior of machine learning and deep learning models. If we don't correctly tune our hyperparameters, our estimated model parameters produce suboptimal results as they don't minimize the loss function. So I did hyperparameter tuning for those selected best 6 models in order to get the optimal results. For machine learning models, grid search was used. In grid search, we try each and every combination of values and calculate some performance matrices using cross-validation. For deep learning models, Keras tuner was used. Then I used those observed optimal hyperparameters for selected best selected 6 models and evaluated those model performances on the test set. When move on to the best 6 model performances on the test set, these are the observed accuracy, F1 score, and AUC ROC values. You can see that RNN with fastest embedding outperformed other models. In this study, we have identified and introduced best features and classification models that can be used in Sinhala hate speech detection with machine learning and deep learning. 5 different machine learning models and 3 different deep learning models were conducted. Among those models, RNN with fastest embedding has the greatest AUC ROC of 0.71 with 70% accuracy for the test set. Then character trigram features surpass all the feature types in machine learning models. when comparing machine learning models and deep learning models for detecting hate speech in Sinhala, deep learning models outperformed machine learning models. There are some limitations in this study. Some users used many forms to indicate the same word. When considering the words, these two words, they are the same word, but here it is represented as two words. So in the feature vector, there are two positions to the same word. And the main goal of this study was to identify hate speech. Now further study of machine learning was done to determine which community, which sub-community or group of people a particular hate speech targeted. Social media is a platform where people from various social and religious cultural backgrounds may interact and communicate with one another. As a result, identifying the target group for hate speech content will be a critical information for the hate speech detection procedure. And the lack of this feature can be regarded as a limitation of this study. Then there are some future works can be carried out for this research. It is possible to use unsupervised learning techniques to identify single hate speeches because only supervised learning approach was used in this study. It can be used to evaluate the performance of stacking approach for detecting hate speech for Sinhala. Stacking has the advantage of combining the skills of several high-performing models to produce predictions that surpass any single model in the ensemble on classification or regression models. And the deep learning models such as BERT and GRU were not used in this study. So those model performances on single hate speech detection may also be carried out. Thank you, everyone.
Thank you, Sim. Yeah, so we can move into the Q&A session. So judges, do you have any questions?
Hi, Swami, Dinusha here. Yeah, it was also a very relevant topic these days and very well presented. I just have two simple questions. One is you presented that you presented there are 3 data sets you used, right, to train the model. So what I saw is they were very well balanced, like, yeah, 50-50, around 50-50. Was it like that actually, or did you apply any techniques to balance the data set?
Sorry, I didn't apply any technique. I used 2 training data sets and 1 test set which I was collected. Pre-collected data sets were used from one from Kaggle and one from UCSC. From UCSC. That's it.
Okay, so your 3 data sets were from 2 different sources, right? Or you used everything in one set and used a sampling technique to randomly select or something? No, right?
I didn't use that.
Okay, see. That's it from me, Thiraj.
Yeah, hi, Sumi, Thiraj here. Great presentation, as Dinusha mentioned. I had a couple of questions. One was I was about to ask you why didn't you try models like BERT or GRU, but I think you mentioned that in the future you'll be using it, right? So that was one which I wanted to ask, and you mentioned that. The other one I wanted to check with you is, like, you mentioned a couple of limitations, and the first limitation is, having those similar, not similar, like words which mean the same thing but written in different letters, using different letters. How do you think you can overcome that in your future research?
It is difficult task because we have to go through all of these our word list and see what are the words, and we have to manually, if we have do that manually, also else we can do it by using Python. But first thing is we have to identify those things. It's difficult.
So technically, it's more of a manual process which we might have to go through, right? Yeah, great. Good. Akshila, over to you.
Thank you.
Yeah, also if we have any questions from the audience, we would like to take them too. If you have any questions, you can raise your hand, so we can take it. Yeah, so seems like there's no questions. So yes, thank you, Sumi, for your presentation. So it was really interesting, and I think it's again a timely discussion that we need to take up, and it will hopefully kind of contribute to reduce the cyberbullying cases and all. So thank you very much. And let's move on to the 10th and the final presentation we have for the day. So we have anomaly detection in image streams with explainable AI by the team Bits of Erised. So we have Nethmi Wijesinghe, Rashmi Perera, and Nethmee Sellahewa. So they are from University of Moratuwa and they hold BSc Hons in Information Technology. So this research proposed a novel framework for the early detection of anomalous behaviors in the present image streams. So over to you guys. So can you guys first start your videos and state your name, please?
Hi everyone, I'm Nethmi Wijesinghe from Team Bits of Erised.
Hello, I'm Rashmi Perera.
You guys have one.
Yes.
Yeah, Nethmi, we can't see your video actually.
Is it good now?
It's not visible for me.
Okay, let me. Now you can see, right?
Yeah, I can see. Okay, so you have shared your screen as well. So I will start the timer now and you can start. Good luck, guys.
Thank you. Good afternoon, we are Team Bits of Erised and we will be presenting on the topic anomaly detection in image streams with explainable AI. So meet our team. Bits of Erised consists of 3 members, myself, Rashmi Perera, Nethmee Sellahewa, and Nethmi Wijesinghe from the University of Moratuwa, and we are supervised by Dr. Priyanka Talagala. So in today's world, there is a large availability of high-quality image streams that can be used for various research purposes, including anomaly detection, through which we can provide real-time support in applications such as deforestation, volcanic eruptions, and flood situations as depicted in the GIFs here. These are also the datasets that we have used in our research. The previous slide contained 3 real-world applications that our solution can be applied to. But not only the Amazon, deforestation is also one of the most serious environmental issues in Sri Lanka, with an annual average rate of 1.14%. Similarly, there are other cases such as habitat degradations, crop diseases, and forest disturbances as well. Now, this is where we see the need of a system which can identify such situations in early stages so that we can take precautions beforehand.
Now let us look at the novelty of our system. We have mainly identified 5 research gaps that we can address in currently existing methods. The first is that the existing methods treat anomaly detection problems as a supervised learning problem. This approach works well with the known anomalies but fails to detect new ones which are not present in the training set. Hence, the generalizability of the existing methods is low. As a solution to this, we propose a novel anomaly detection framework where we treat anomaly detection problem as one class classification. The next research gap we have identified is that the most of the existing methods ignore the interdependency or the inherent order of the images. We integrated computer vision and time series forecasting to capture the interdependency between the images during the model building process. The third research gap is that most of the existing anomaly detection methods use manual thresholds and unrealistic assumptions. We proposed a novel approach to calculate a data-driven anomalous threshold using extreme value theorem. The next research gap we decided to address is that the existing deep learning-based anomaly detection methods solely focused on the classification task, which leads to the lack of explainability of the model. This reduces the human trust on the system. In our proposed framework, we integrated explainable AI along with computer vision and time series forecasting to detect anomalies in image streams. The last research gap we have addressed is the class imbalance problem. To address this class imbalance problem, some researchers have used different approaches like upsampling, downsampling, data augmentation, etc., which have their own limitations. So in our proposed framework, we treat anomaly detection problem as one class classification problem and build the model for the typical behavior. The aim of this research is to develop a novel framework that detects and interprets anomalies in image streams using computer vision, time series forecasting, extreme value theory, and explainable AI. There are mainly three objectives of this research. The first one is to define a pool of features that encapsulate the signal information contained in image streams using computer vision. Second is to propose a novel framework to detect anomalies in image streams in different application domains using time series forecasting and extreme value theory-based anomalous threshold. And the last one is to implement a suitable explainable model for anomaly detection in image streams. So the methodology we worked out is presented in next few slides. In our research, we have defined an anomaly as an observation that is very unlikely given the forecast distribution. Our proposed framework is mainly based on two assumptions. The first one is we expect that an anomaly shows a significant deviation from the typical behavior of a given system. The second assumption is that a representative data set of the system's typical behavior is available to define a model for the typical behavior of the image streams generated by a given system.
Shown here is the proposed methodology, which consists of two machine learning and deep learning based anomaly detection modules and an explainable AI module. The two anomaly detection frameworks are subject to comparative analysis in the research, and the explainable AI module ensures the increase in the explainability of the black box models. This is the overview of the machine learning module for anomaly detection. It has an image processing, a feature extraction, principal component analysis, time series forecasting, and classification components. The first component, image preprocessing, takes an image series dataset as an input and improves its quality before feature extraction. The images are cropped, smoothed using the Gaussian filter, and contrast stretched. Next, the image dataset is used to extract features, and 4 different types of features are extracted, including first-order statistical features, Gabor wavelet features, edge detector features, and gray-level co-occurrence matrix features. So a total of 87 features were extracted by this component. Next, the large feature set is dimensionally reduced using principal component analysis to obtain a univariate dataset, which is then split into training and test sets. This training set is used to build an ARIMA-based time series forecasting model.
This is the overview diagram for the proposed framework for the deep learning-based anomaly detection module. The process of this module is very similar to the conventional machine learning module. In the pre-process stage, we use 3 techniques: image cropping, resizing, and normalizing. Afterwards, we use pre-trained convolution neural network architectures to extract features from the images. Here we compare the performances of 5 pre-trained CNN architectures, namely VGG16, ResNet 50, Inception V3, Exception, and DenseNet 121, to choose the best model as the backbone of the feature extraction model. To extract features from the CNN, we remove the top fully connected layer from each and add a global max pooling 2D layer to get a single feature vector for each image in the dataset. To obtain a univariate feature series, then we get the average of feature vector for each image, and it is then split into training and test sets. LSTM-based time series forecasting model is built using the training set. Following the ARIMA model of the machine learning module and the LSTM of the deep learning module, we obtain a residual and the forecasted error series. The residual series is used to calculate the anomalous threshold, and then we classify the data points in the forecasted series as an anomalous behavior if greater than the calculated threshold value, else as a typical behavior.
A lot of existing threshold calculation methods are based on unrealistic assumptions. The infamous box plot based threshold calculation assumes that the dataset will conform to a normal distribution, which will not be guaranteed all the time. As a solution, we propose extreme theory based anomaly threshold calculation. As anomalies have a lower probability of happening, the extreme values can be considered to represent anomalies. Therefore, in this technique, a child distribution for the generalized extreme values is plotted, and using that distribution, the threshold calculation is conducted. The above diagram summarizes the steps of this calculation. So moving on to the explainable AI module. Since deep learning techniques act as a black box model, leaving the understandability and the trustworthiness at stake, explainable AI provides the explainability and the interpretability. As this is a fairly new area in AI, it is very important to conduct a proper survey to understand the domain. In this diagram, we have gathered some important terminology, concepts, taxonomies, and overall challenges, as well as some popular methodologies. The yellow-colored areas are what have been adapted to our study, and the taxonomy given here is used as the basis for our study. The overall challenges that we chose to solve are the problem of adapting XAI into real-world scenarios and the trade-off between accuracy and explainability. For that, we have chosen model-agnostic explanations in the local scope, and the CNN feature extractors are the black box models for which we provide the explanations. As for the XAI techniques, LIME and SHAP have been selected. SHAP and LIME both give model-agnostic post-hoc explanations, and hence the accuracy of the original model is not compromised. Both methods aim to identify the importance of each feature towards the prediction of the black box model, and LIME and SHAP both decomposes the image into superpixels and create a dataset by turning on and off the pixel values and getting the prediction from the original black box model. After that, SHAP and LIME follows a different approaches in calculating the feature relevance. As in the slide, SHAP takes various combinations of the feature set and calculate the marginal contribution based on game theory. And finally, considering all the marginal contribution of a feature towards the prediction, the total contribution is obtained by using SHAP calculation. On the other hand, LIME uses an inherently interpretable local surrogate model to approximate the feature importance. LIME can only give you whether a specific feature is contributing to the prediction or not, whereas SHAP can also give you the degree of contribution. Even though the existing LIME and SHAP methods give reliable explanations, they cannot be applied directly to a combination of black box models. Thus, in order to approximate the explanations from the feature extractors, we have constructed 3 proxy CNN classifiers, providing the same grounds as the deep learning anomaly detection module. And as shown in the diagram, the classification outputs obtained from the CNN classifiers are then separately gone under SHAP and LIME explainers, and each method provides the feature maps with the relevant feature scores indicating the feature contribution. This way, we approximate the explanations in terms of the feature importance of each CNN model used, and as the feature extraction lays the foundation for the anomaly detection.
Now let's move on to the evaluation and the results of the proposed framework. To evaluate our models, we used 5 metrics: accuracy, specificity, sensitivity, positive predictive value, and negative predictive value. When using the deep learning techniques for the small data set, the VG16 LSTM model with 90% accuracy outperformed the other 4 models, and for the large data set, Inception V3 LSTM based model with 99.6 accuracy has given the best results. When comparing the results of the machine learning based models with the deep learning based models, we observe that machine learning model with an accuracy of 98.3% outperform the deep learning based model for the small data set, and for the large data sets, the deep learning based model clearly outperform the machine learning based model. Another important observation we made from the result we have obtained is that our proposed EVT-based threshold calculation method outperformed the box plot-based threshold calculation technique results in each situation.
And when we compare the time taken for the feature extraction using both the machine learning and deep learning models, we observed that CNN-based deep learning models took much less time to extract features compared to the machine learning model for both datasets. Moreover, we observed that Inception V3 and DenseNet 121 CNN architectures took less time compared to the other three CNN architectures. And to prove the generalizability of the frameworks, this table displays the results obtained by the machine learning and deep learning frameworks for an additional dataset that depicts an undersea volcanic eruption. It can be seen that both frameworks provide good results for both the datasets, and this generalizability adds to the novelty of the research, as was mentioned previously.
To give local explanations, we have chosen the 100 and the 1900 images from the normal class and the 2250th image and the 2450th images from the anomaly class to evaluate the slow changes of the normal class as well as the rapid changes once the anomalies are detected. In line explanations, the green color spots are the superpixels that has contributed to the final prediction in a positive manner, whereas the red spots are what have been influenced negatively. As we can see, ResNet 50 and Inception version 3 have identified the most appropriate regions as major contributing areas when identifying an image as whether an image has an anomaly or not, compared to the VGG16 model.
You have one minute, please.
In SHAP explanations feature maps, the variance of pink and blue spotted areas indicate respectively the positive and negative contribution towards the prediction. And the higher the intensity of the pink and blue color, the more negative and positive the contribution is. Aligning with the line predictions, SHAP predictions also indicate that ResNet 50 and the Inception version 3 have correctly identified the feature for each prediction. With that, let's move on to the further work. The machine learning module can support a more optimized feature extraction and selection process, and the deep learning module can be further optimized to accommodate to smaller data sets. And moreover, there are a lot of good hyperparameter tuning methods. Since our focus is a little bit different, we have only checked few hyperparameters and left the rest for the future work. And for the explainable AI, a proper evaluation method for XAI component can be introduced because with the novelty of the domain, we are short of suitable evaluation techniques for explainable AI. Thank you.
Your time is up, guys. So thank you, team. Judges, do you have any questions for the team?
Hi all, I'm Dinusha here. So the research is very well planned and organized, very well done.
Thank you.
The first question I have is, you mentioned this is this detection method is for streaming data, right? Is it streaming or okay? So for the streaming aspect, did you maybe what did you do for the streaming aspect of it? Computation? Did you try to reduce the computational complexity?
We actually use image streams, as in we split like the datasets that we originally obtained were GIS, but then we split the datasets into individual frames, and that was how. So it was basically a series of images. And as for computational complexity, we didn't do any optimizations per se. It's we plan to do it as keep it as further work. But the machine learning module took a lot of time, whereas the deep learning module was a lot more optimized. It modeled the behavior in a very short time.
Okay. Just one more question. Is this application-oriented technique, or it's kind of generalized across applications? I mean, like, I think it's generalizable because you are dynamically finding threshold, right? Is it?
Yes, it's a generalized, more generalized based application. We tested it for the deforestation data set and another again tested for a volcano based data set. So we can generalize it based on the application.
Okay. Okay, that's all from me. Thanks.
Thank you.
Yeah, hi team. This is Thiraj here. Great work, great research. A couple of questions on my side as well. You did mention in the further work that you have done a few hyperparameter tuning. Can you mention what parameters you managed to tune?
Actually, we have not used any techniques to tune hyperparameters for now. We leave it, left it for the future work. We used manual methods to train few hyperparameters like the time steps in the LSTM model. Likewise, haven't used any like proper technique to tune hyperparameters.
Understood. Good. Also, I saw that you had around 87 features in the machine learning model.
Very excited to see like who are the winners. So let us not wait anymore. So I would cordially invite Asanga Gunawardena from the panel of judges to share a few general comments on the symposium and also to announce the winners. Over to you, Asanga.
Thanks, Anurangi. Yeah, I think overall I must say that everyone did like a great job. And even when we looked at all the scores, it was like all the scores were pretty much in a close range, and it was a difficult task for us to choose winners. So I want to congratulate everyone on their first, before I announce the winners, congratulate everyone on their putting a great effort on doing the research, and as well as submitting this for this analytics symposium, and then also working on the presentations and the effort that you have put into spend your time here today. So congratulations to everyone, and thanks for putting across this effort. It's really appreciated by us. Saying that, let's few general comments. I think all the presentations they had followed a good structure. The content was rich enough in the most of the presentations, like whatever they presented. And then I think it's also important in the current context that we are not doing this physically. So to maintain that eye contact, and easily, like when you're doing these virtual events, everyone could get distracted easily. They could be doing other things. So I think most of our presenters, they maintain to keep the audience or judges and everyone attracted to whatever they are presenting. So that was like a really good plus point that I saw in most of the presentations. So yeah, those are some of the general comments that I could give. I think since everyone's eagerly waiting for the winners, I won't drag this anymore. Are we going to show this on a slide, Anurangi, or will I'll just announce it?
Just announce it, Asanga.
Yeah. So the first, let me start off with third place. So third place goes to Devminda. I think this was the research where he was the model was applied to predict the reliability of each article. Yeah, on general comments, I think all the judges said that the content was well structured, and your communication or the way you presented was effective. You put out your points across and like highlighted important points correctly. And then this was also a topic, what we had chosen was addressing something like current or something problem that we face in the current context. So congratulations, Devminda. And yeah, the second place goes to Pamal. Again, judges said that this was his research was nicely structured, including business value and technical contribution. It was also technically solid and particularly good how you tried to be very relevant with the issue and then the business. Yeah, and then I think finally it was team's bits of Erised. I hope I pronounce your name correctly. Yeah, again the judges said it was well structured and you had done a lot of background on the other researches that you was carried out on this topic. You managed to clearly identify the research gaps, and then whatever your research, how you sort of close this gap or how you address this gap. So that was clearly identified in your presentation. And then you had also tried different approaches in solving this problem, and then your conclusion was on point. Yeah, congratulations, teams bits of Erised.
Thank you, sir.
Very well done. Yeah.
Thank you.
Thank you, Asanga. So again, congratulations. So team bids of Erised, Pamal, Nanayakkara and Devminda, Abeynayake, congratulations. So the winners will be contacted by the team of OCTAVE to receive their prizes. So with that, we have reached the end of the OCTAVE Advanced Analytics Symposium. Now let us welcome Dr. Rajitha Navarathna to deliver the vote of thanks. Over to Rajitha.
Thanks, Anurag. Hope you can hear me. Yeah, okay, cool. Thank you. So congratulations for all the winners in this symposium, but for all the other finalists as well. So we were really enjoying your presentations, and we really actually impressed the way that presentations have gone from starting to end, right? Especially the way you have structured the presentations and looking at the data, especially to be in this particular field. So and pretty good effort from everyone, right? So you should be really proud of your efforts. So let me take this opportunity to thanks on behalf of OCTAVE, the John Case Group Data and Advanced Analytics Center of Excellence. So I would like to extend my heartfelt gratitude to all the finalists, and there were one finalist from UAE as well, Jimmy. So it's good to see that there are some interesting from outside of Sri Lanka as well, and to be part of this analytical symposium. And also for all the judges and the admin staff who actually worked in the backstage to make this particular event in a successful, and all the audience that who have participated in this particular OCTAVE Analytical Symposium. And we wanted to make sure that from the next year onwards that we will provide the opportunity for you to ask questions as well, due to the limited time and due to a virtual event. But we'll take these comments as a positive comments for have it in the next year. I wanted to thank everyone who participated this event. And as OCTAVE, we wanted to start this analytical symposium to give an opportunity for Sri Lankan students. Plus, it's good to see that there are some interesting from outside of Sri Lanka as well, to give like a platform to you to come and present your research, finally research, which is connected to the data science, machine learning, and maybe big data concepts, and also data security, those kind of heavy areas, to give a platform for you to come and present it to our OCTAVE expertise, and then get the relevant feedback for you to make it more successful on your project, and also to give you opportunity to connect with OCTAVE staff as well. So that was like our motivations to have this symposium, and this is our second event, which we virtually hopefully we can do this event in physically in next year, right? And so again, I would also like to thank all the finalists for making their presentations during the last 1 or 2 weeks, and we had got several abstract, and then we have selected 10 finalists for today's event. And all the people who submitted the abstract and who are not in the finalists, we would like to thank as well to take some time and provide your abstract to OCTAVE to look into your research. And hope all of us learn some interesting stuff from attending this seminar, and we hope to see you hopefully physically in next year event at OCTAVE Third Symposium. Hopefully will happen in 2023 April and May. And please follow OCTAVE on LinkedIn to get updates on the future events as well. So the admin staff will put all the relevant information in LinkedIn. And recording of this session will be available in YouTube channel as well. And before you wind up for the day, please fill the feedback form, and admin staff will put it in the chat to get some comments and any suggestions that you have to make this event in a successful way. And again, congratulations for all the winners, and good afternoon and stay safe. Thank you, everyone.
Thank you, Raj.
Thank you all, and let's meet you guys in 2020 physically.